A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre. And even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed a space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, space safety and security applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19 Plus, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive. Launch a mission to a unique point in space known as L5. By taking a
From Portugal, ladies and gentlemen, the ceremony will begin in a few moments. We kindly ask you to take your seats and remind you that the use of face masks is mandatory. And don't forget to silence your phone the entire event. Thank you.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed a space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, space safety and security applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission.
Good afternoon, ladies and gentlemen. Welcome to the pitch day of NATO Innovation Challenge ceremony. His Excellency, the Portuguese Minister of Defense, João Gomes Cravinho, will deliver the welcome remarks. Please, Mr. Minister. Excuse me.
General Paulo Ruggiero, Deputy Supreme Allied Command and Transformation, Sr. Diretor-Geral dos Recursos de Defesa Nacional, Sr. Tenente-General, Comandante do Instituto Universitário Militar, Srs. Oficiais Generais, em representação dos chefes dos ramos e Srs. Dirigentes do Ministério, caros oficiais, militares e civis presentes e também, naturalmente, aqueles que nos acompanham por videoconferência. Distinguished members of the jury of NATO Innovation Challenge Pitch Day 2021 and, of course, finalists of the NATO Innovation Challenge. Firstly, let me congratulate the 10 finalists in this competition, and let me wish you the best of luck for today's pitch of your projects to NATO. Reaching this stage of the competition already testifies to the quality and to the relevance of your ideas for NATO. For the Portuguese Ministry of Defense and for the Portuguese Armed Forces, collaboration with the 2021 NATO Spring Innovation Challenge is a great opportunity, not only to engage with this stimulating community of experts, but also to showcase what Portugal is doing to promote innovation in defense. Innovation, of course, may come through technology and equipment, but it can and should come through the development of new procedures and new ways of working. Innovation in perspectives and processes is as important as innovation in technology. Open environments, which promote strong civilian and military cooperation, will remain critical for this endeavor. NATO's commitment to innovation is not new. In fact, the secret of the success and resilience of the Atlantic Alliance over these more than 7 decades largely lies in its culture of innovation that has allowed it to adapt successfully to new challenges and threats. This culture of innovation had its most significant institutional expression in the creation in 2003 of NATO's Allied Command Transformation, which was mandated to lead the development of military structures, forces, capabilities, and doctrines, and enabling NATO to meet its level of ambition and core missions in a rapidly changing global defense and security landscape. As was underlined in the latest NATO summit just 2 weeks ago, allies are committed to fostering technological cooperation in NATO and to investing accordingly. This is key for the alliance to remain a credible deterrent against strategic competitors. This is also key for effective interoperability between allies. The establishment of a NATO Innovation Fund, which was conceived to support the development of dual-use emerging and disruptive technologies in key areas to allied security, is further proof that innovation will continue to be a key driver of change in international security. Portugal is committed to this culture of innovation, and so we are taking important steps in this direction, stimulating dynamic ecosystems that gather industry, scientific and technological knowledge, and military experience in several key areas. In order to transform defense organizations into active agents of innovation, fully integrated into the knowledge society, we must be committed to this inclusive approach. This is what we are promoting through our holding company, the IDD, Portugal Defense, and this is also what we aim at with the establishment of the Department for Innovation and Transformation at the General Staff of the Armed Forces, amongst other examples. But keeping NATO's innovation edge can only be done by tapping into the world's best talents. Therefore, creating an open and large community of experts, scientists, students, etc., from all over the world to deliver innovative solutions to specific needs is a formidable way of getting this vital job of transformation done. This contest focused on space domain awareness. This contest is focused on space domain awareness, so allow me to say a few words on this topic. The combination of new perspectives and technological development has become the basis for what has been called the new space. Imagining new possibilities in space and creating the necessary technological solutions to make these possibilities a reality has pushed space exploration further. Space competition was a permanent feature of the Cold War, and this required significant investments, but also it required the adoption of common rules to ensure that this global common was not used for malicious purposes. The last decades have seen an increased interest in space development. This has largely been driven by private investments and has led to new possibilities in the use of space for the development of our societies. Today, large segments of the world economy rely on space-based technology, namely communications and transportation, but much else beside. Other areas, including military operations, also rely heavily on space-based technology, and this dependence will increase in the future. At the level of the European Union, space has assumed strategic importance, leading to the establishment of a Directorate General of Defense Industries and Space. Investment in this sector has been reinforced, tapping into the new resources that are made available with the development of the EU's defense policy, including PESCO projects. It is of vital importance to address vulnerabilities in European value chains and existing dependencies on non-European technologies and components. The future of our resilience, both in the civilian sectors and in military operations, will be largely dependent on this. This reality is also relevant for NATO, and this was clearly stated in the NATO summit communique earlier this month. As we head towards the development of a new strategic concept for the alliance, the role of space in NATO's warfare development needs to be fully recognized and considered. Space has been identified as a key variable in the security and prosperity of our nations, and for NATO's defense and deterrence. NATO committed to accelerating work to deepen and expand our use of space as an operational domain, in full respect for international law, and through the promotion of responsible international behavior in space. Allies also agreed and stated publicly that attacks to, from, or in space could justify resorting to Article 5. But for this commitment to be a credible deterrent, innovation needs to continue as we update our capabilities and our approaches. Therefore, each of today's contenders should pride him or herself and their teams for contributing to making this alliance of democracies more robust, more committed to peace and security, and more capable of delivering also in space. Portugal remains committed to these developments, both by developing our national industrial and technological ecosystems in articulation with our European and allied partners, namely with the establishment of the Portuguese Space Agency and the adoption of a national space strategy, but also by developing our strategic needs for security and defense, by adopting a defense strategy for space, invested in Earth observation as our participation in the Space Surveillance and Technology project of the European Union illustrates. Similar to other major topics in NATO, space is a significant area of cooperation with the European Union. There is a win-win logic here, reinforcing the commitment of allies and European Union member states around a transatlantic bond for the future. This has at its core the security and the prosperity of the region around the Atlantic Ocean. I would like to end by thanking the teams at the Portuguese Ministry of Defense and in Portuguese Armed Forces for their work, particularly to this institution, the Instituto Universitário Militar, for hosting us, as well as to NATO's Allied Command Transformation, for once more recognizing Portugal's ability to deliver and to be a reliable partner, also in this kind of initiatives. And the next event will be in Canada. So I wish Canada a great deal of success in its organization of the next Innovation Challenge. And of course, I wish all of the participants the best of luck, and I hope you can enjoy your days in Lisbon. Thank you.
Now we invite the Deputy Supreme Allied Commander, Transformation, General Paolo Ruggiero, to address the audience.
Your Excellency, distinguished guests, admirals, generals, authorities, ladies and gentlemen, good afternoon and good morning for those who are connected, I think, on VTC from the other part of the ocean. So let me say, first of all, that as Deputy Allied Command Transformation, it's a great privilege for me, of course, to co-chair this ceremony, and especially this 8th edition of the ACT's Innovation Challenge, which, as you know, is co-organized by the Allied Command Transformation in Norfolk and the Portuguese Ministry of Defense. And so I want, first of all, to thank Portugal, this great nation, a great ally of NATO, for its kind and warm hospitality. And in particular, I would like to thank the Ministry of Defense, Mr. Gravino, the Portuguese Chief of Defense, who will be present this afternoon, Admiral da Silva Ribeiro, but also I would like to thank Mr. Vasco Hilario, the Director General for National Defense Resources, and the Director of the Military University Institute, General Ferreira, for his great hospitality and warm hospitality here. So thank you very much. And also on behalf, of course, of General Andrea Nata, the commander of the Allied Command Transformation, let me say that, again, thank you very much, especially for the possibility to host this special event here in Portugal. And as you know, ACT has, let's say, a strong bond, a strong links with Portugal, because this is also the home of the Joint Analysis and Lesson Learned Center that I just visited this morning. And also we are working very closely with the Minister of Defense of Portugal for the accreditation of another center of excellence in the network of the Alliance Center of Excellence, the GeoMetoc Center of Excellence, who's also is here in Lisbon and that I visited yesterday. So my great appreciation really for the effort that Portugal is putting in all the NATO initiative. Let me also say that I really appreciated, Minister, your words regarding in recognizing ACT role, especially in leading the innovation within the Alliance. The Innovation Challenge is for sure a project of major interest for the Allied Command Transformation, because its innovation is one of ACT's top priorities, and it will even be more in the future. As we all know, and you mentioned, sir, this during the last NATO summit in Brussels, all 30 nations of the Alliance approved the so-called NATO 2030 policy, the new strategic vision and way ahead for the Alliance that was presented by the Secretary General. Well, one of the key pillars of NATO 2030 specifically regards innovation and its implication, highlighting the needs for the Alliance to boost all available initiatives and offer and efforts in order to maintain our technological superiority over any potential adversary or competitor. So in this regard, for many years, the Allied Command Transformation in Norfolk has played an important role as a focal point of the Alliance for the study, research, experimentation, and application of innovation in every phase of the warfare development. In ACT, we established in 2019 an innovation hub to exploit the opportunities and to address the challenges posed by emerging and disruptive technologies in conjunction with a wide network of partners, industry, academia, universities, center of excellence, center of research, startups, and even individual expertise. Therefore, due to this robust and well-recognized capacity, ACT must and will play an essential role also in the implementation of the intents included in the NATO 2030 documents regarding innovation. The event of today is just an example of our strong commitment and effort on innovation. Let me also say that this 8th edition has been particularly significant for 3 reasons. First of all, because we have the possibility to be physically present here after more than a year of restriction due to the pandemic. Secondly, because the theme of the challenge, as was mentioned, is centered on the space domain awareness and its military implication in terms of collection analysis and in the use of information to facilitate an effective decision-making process, especially at the strategic political level. And we all know that the space domain today is very challenging, is changing fast, is very competitive, contested, and congested from many actors that are playing a very important role in the space domain. And finally, I think that this edition is very important also for the quality and quantity of the participant. We have more than 41 different solution proposals that were presented from 12 nations. And so I think this was also a great success, considering also the limits of the pandemic for this edition. To solve new issues like the development of special military capacity of the future, we need to also rely on innovative solutions from a wide network of experts from outside our daily environment. And after today, I hope that not only one, but many of the proposals that will be presented today, the proposed solution that will be presented today, will become a real capacity project to strengthen our alliance in the future. And I want to congratulate every participant, especially the 10 finalists today. I wish good luck to all of you, of course, to be the winner, but you all are the winner from my perspective, because just the fact that you arrived to this final stage, I think you are a winner for sure, for the importance of what you are presenting. And I would also like to thank, of course, all the people who were involved and worked really tirelessly to finalize this challenge, the people from ACT, but also, of course, all the other personnel that was involved, especially coming from the Portuguese Armed Forces. So again, my special thank to Portugal, to the Portuguese military authorities for their remarkable contribution to the alliance and for the outstanding support that we received in coordinating this event. We'll see each other this afternoon later on to announce the winner. So I wish to all of you all the best, good luck, and thank you very much for your kind attention.
Thank you, Mr. General. We will then proceed to the presentation of the members of the jury. So, I would like to invite Mr. Serge Dadepo, one of the founders of the NATO Innovation Hub of Allied Command Transformation, to take the floor and introduce the respective members of the jury.
Hello, everyone, ladies and gentlemen. It's a privilege to introduce the members of the jury because they are really presenting the collaboration that is a principle of innovation in NATO. Organizing an event like this one supposes to gather as many expertise, as many partners as possible. And I think for this 8th iteration of the NATO Innovation Challenge, we have a wonderful panel of experts who represent the most trustful partners in organizing this innovation challenge on space awareness. And so to start first, I would like to introduce those who made today possible, actually the Portuguese representative in the jury. And we have a representative from the Armed Forces in the person of Brigadier General Paulo Almeida, who is director of the Department for Innovation and Transformation that was created not so long ago as making innovation really happen in Portugal in the defense for the first time. Also from Portugal, we have the chance to have the Portugal Space, which I would nickname the Portugal Space Agency, with Mr. Eduardo Ferreira, their vice president. After the Portuguese host, we have support from many experts in the field of space coming from different places. Some actually members of the jury are on site with us here. Some are also online, but they are actively participating to the selection that will happen very soon. And so we have the US Space Agency, NASA, represented online by Mr. Kevin Rivers, who is head of innovation there. And as well, the European Space Agency, represented by Mr. Frank Salzgeber, who is also head of innovation there. What is on the list? The NATO people also are there. So we have the chance to have a representative of the NATO international staff. So for those who know the structure, it's Brussels, the civilian part from the Secretary General, and we have Mr. Jacques Lasry, who is the senior space officer. So representing exactly what NATO could do with the solution that we will find today. Also from NATO, the Science and Technology Organization is represented by Lieutenant Colonel Roderick Bennett, who is at the Collaboration Support Office in Paris, actually, in charge of one of the panel dealing with the space issues equally. We also have the support from nations, and France is contributing to the jury in the person of Colonel Jérôme Dufour, who is head of the preparation of the future division of the French Space Command. With him, because they are online, are sitting representative from their armament directorate and for the National Center for Space Studies. So all these persons are part of the jury, which is headed actually by, last but not least, someone from Allied Command Transformation. The chairman of this jury is Brigadier General Paul Prindal from the Danish Army, Assistant Chief of Staff for Requirements in Norfolk, Virginia, NATO Transformation Command. And so I got through my list. Everyone, oh no, last but not least, I forget our preferred academic partner. And for those who are watching this for the first time, we have created the NATO Innovation Hub, this innovation challenge, with the support from the outset from Old Dominion University. And they are represented today in the person of Mr. Martin Kazubowski, who is the director of their Innovation and Entrepreneurship Center. And they've been there with us from edition 1 to edition 8. And on top of it, he's also a space expert. And so to be sure I'm not upsetting anyone, I'll go through the list again. I have everything. Thank you so much for your attention and for the job that you will be doing, members of the jury. You are the person with the most difficult job to do today, that lasts for 10 times 12 minutes, while the presenter will have only 1 time 12 minutes. Thank you so much, and thanks to everyone in the public.
We declare the welcoming ceremony closed. The finalists will now prepare their presentations. The first team to present will be VisWorks and University of Calgary from Canada, represented by Mr. Jeff LaFrance. We now invite you to a 10 minutes break. Thank you.
Thank you.
Hello again. So we are ready to start. We'll then contact the Visworks and University of Calgary and the team leader, Mr. Jeff LaFrance. Hello, Jeff.
Hello.
Hello, how are you?
I'm very well, thanks. How are you?
I'm fine too. Tell me, Jeff, are you nervous to be the first team to present your idea?
A little bit, of course, but also very excited by the opportunity, for sure.
Okay. Tell me, Jeff, do you know the rules of the presentation?
Yes, 6 minutes for our pitch and then 6 minutes for questions.
Oh, yes, good, great. So, Jeff, are you ready to present?
I am ready.
Okay, so Visworks and University of Calgary, go for it and good luck. The floor is yours.
Thank you very much. I'll just share this. All right. So thank you. It's a pleasure to meet you, and thank you to the jury and to the members of the broader NATO community. We really appreciate the opportunity to present our 3D collaborative space situation awareness system to you. Visworks solutions empower the human in the loop utilizing the latest in human engagement technologies, such as augmented reality, virtual reality, artificial intelligence, and complex data visualization. We create enterprise digital experiences that drive deep understanding and inform decision-making. Our University of Calgary partners are experts in space data acquisition, analysis, and application. They have deep experience with space data sources, including designing, building, and operating the world's foremost observational facilities for high-latitude ionospheric observations. Together, we are a team of over 60 people supporting near-Earth space environment research and application. The space data environment is multi-sensor, highly heterogeneous, and continually evolving. Space domain awareness requires combining data from multiple sources to extract meaningful information and present it in such a way as to enable informed and timely decision-making. 3C SAS blends the latest in multi-source data, physical and predictive space environment models, and visualization technologies to enable NATO personnel to easily understand the key space-related conditions that drive your operational and tactical decisions. One of our Canadian advantages is the single biggest readily accessible landmass under the sub-auroral, auroral, and polar cap regions. This has given our team tremendous experience in both developing and utilizing a variety of high latitude space environment sensors to observe and characterize the dynamics of the near-Earth space environment. From this, we can predict the impacts on space system performance and visualize this for situational awareness. Shown on the top are sources of diverse data that we assimilate into our space environment models. As shown in the bottom, utilizing these models, we can assess the impact of ionospheric phenomena on GNSS and LEO satellite communications. Utilizing our 4D ionospheric models, we are also able to create 2D terrestrial maps that show estimated risks to GNSS positioning, navigation, and timing. The result of this and other work is generation of actionable information for space operational and tactical decision-making, including differentiation between human-made and natural perturbations of the environment. Covering aerial through to space domains, we are able to generate HF propagation metrics from our lower altitude ionosphere characterizations. To do this, we exploit unique ground sensing systems based on our rheometer technologies. Our team's use of rheometer technology allows us to measure HF absorption from 65 kilometers to approximately 120 kilometers altitude, a very effective way to observe this lower altitude region. The resulting models allow us to estimate the physical properties affecting HF propagation, informing applications such as communications, space asset tracking, threat detection, and many others. However, our ability to make informed decisions is only as good as our ability to access the right data when and where we need it, and to access the right people to support the decision process. As such, remote collaboration is a common requirement for many of our client solutions. While devices differ significantly in their ability to present information, we have many years of experience in optimizing applications to take advantage of the capabilities of different device technologies, ensuring that our clients will be able to access their critical operational information whenever and wherever they need to. Through observing and characterizing the dynamics of the near-Earth space environment, we are able to extract key parameters and confidence levels for system performance that can be readily presented to operators. Our team has decades of experience in the development and deployment of sensor coverage maps, which include a number of projects for the Canadian and European space agencies, NASA, and the Canadian Department of National Defense. Our latest work is a web-based multimodal interactive visualization that merges information from numerous satellite and ground-based sensor platforms to provide a comprehensive 3D coverage map. And while 2D screens still dominate control room environments, they are not inherently good at conveying 3D spatial information. However, the latest in augmented reality, virtual reality, and holographic display technologies provide intuitive 3D environments that dramatically increase operator capabilities. Our virtual operations environment, or VOE, is a next-gen command and control solution. VOE utilizes the latest in immersive reality and interactive visualization technologies to reduce cognitive load while enhancing operator ability to make informed decisions, locally or remotely. Shown here is an instance of VOE being developed to support Fisheries and Oceans Canada and the Canadian Coast Guard to identify and interdict illegal fishing activities in Canadian coastal waters through a fusion of air, space, sea, and terrestrial-based data. While our combined team has decades of experience in developing systems based on space environment data, the ultimate determinant of systems requirements is NATO itself. Therefore, our recommended process is an initial phase of joint project scoping to ensure alignment between our respective organizations, followed by the iterative build-out of the highest priority NATO requirements and a final phase of advanced capability integration. Thank you again for your time, and we look forward to answering your questions.
And for your amazing presentation. Now we invite the jury. If I asked if you have any questions.
No questions.
Can you hear me?
I can hear you, yes. Thank you.
Thanks, a good presentation and perfectly on time. Congratulations on that. You mentioned that your VOE is better for cognitive behavior and for operator abilities. Is there evidence of that? What do you have that actually proves that's the case?
So there's a tremendous amount of background work that's being done and showing that in immersive environments, particularly 3D environments using virtual reality, provide a much better comprehension of 3D spaces. And particularly when you come down to things like, essentially you can think of a virtual reality environment as an unlimited pixel environment. So you can convey information in ways that's classically not possible in a 2D environment. And particularly bring things into the third dimension. Some of the work we're doing right now, as an example, with the Department of Fisheries, Oceans, and the Coast Guard, is really focused on utilizing this third dimension for things like time, as an example, and showing the spatial relationship of ships moving around in an ocean, but using the vertical axis to show time information in a way that a 2D screen just is not possible to do. And so this enhances people's capability to understand that data, and the research clearly shows that that really improves their ability to understand it and make better decisions ultimately as a result of that.
A question from Frank Salzgiver, European Space Agency. So when you would have a shopping list, Christmas car list, what is the data source you would still missing to have even a more precise, or more optimal, when you speak about data fusion, or more better result? What is the source? That's it.
Thanks very much for the question. Susan, this is one for you, I think. You're on mute. Oh, and she can't come off mute?
Again, you reach me? You copy?
So Susan is the one to answer that, but apparently she's stuck on mute and is not able to come off mute.
Jeff, are you hearing us?
I am hearing you, yes. Can you hear me?
Can you change the micro, please?
No, you hear us, but Susan is not answering. Is that
Susan is on mute, and she's not able to unmute.
Okay, you have to answer it.
Susan, do you have any?
Yes, one question from France.
I'm unmuted. Thank you.
Thank you.
Host. I have a voice now. Thank you. I can speak for the space environment characterization in terms of some of the work we've done recently. And we assimilate about 12 different data sources into our 4-dimensional resolution of the ionospheric characterization. And that's what we use to predict the space weather hazards and the impact on systems. And what we found is significant improvements through using some ground-based riometer data. And these are instruments that haven't been typically used in this assimilative sense. And we're developing our own technologies for those riometer instruments in terms of multi-frequency systems, imaging systems that are directional. And what they allow is really resolving that bottom part of the ionosphere and allowing really unprecedented predictions of high frequency, signal propagation, skywave propagation for radar systems and communication systems, and really allow us to predict the quantities and the impact on the users with the sensitivity of those systems assimilated into our model. So that's a bit of the holy grail of data systems that we choose to assimilate. And we have that opportunity in Canada. And then as we apply our machine learning algorithms, we propagate that model in a predictive capacity for all local time sectors for global specifications.
Yeah. French have a question, please. We need to.
Yeah, Francis.
Thank you.
Here from France, I have a question. Thank you for your presentation. Very inspiring. The question is on the approach you are proposing. Are you proposing to be able to visualize the same event using different so augmented reality, virtual reality, different means of the same reality, or are you proposing to use one of those? And my question is linked with the fact that for operational needs, there are some events for which the 3D or virtual reality may not bring a great added value. So that depends on the situation. And have you think about which are the situations for which your technique and technology will bring the highest added value?
Thank you. That's a very good question. And yes, ultimately, we don't presuppose the technology. We first of all look at the operational conditions and then choose the appropriate technology for that. And because we have experience with pretty much every device technology that's utilized, we tailor the solutions to meet the needs of the situation. And that often means for clients, we have a multi-device environment where some technology, some information in some environments is presented using one technology and in other environments with other technologies. So it ultimately comes tailored to meet the specific needs of the client environment in the kind of solutions we create.
Thank you, Jeff. It's over. Thank you, Jeff, and VisWorks and University of Calgary team. Now we will move on to the next team, Share My Space, who are present in the room. Thank you, Share My Space. Good afternoon, Mr. Arthur Belot et François Mazière. Tell me, can you move to more? Okay. Tell me, it is your first time in Portugal?
Yes, it is actually. For me, it's the first time in Lisbon, and it's a pleasure to be in a physical event and to actually meet people and have an opportunity to present our innovations.
And are you enjoying Visit Lisbon?
We didn't visit a lot of things, but we are enjoying our stay.
Okay. Tell me, are you nervous to present?
No,
Confess.
It's fine. It's fine. We hope we will do better than France yesterday and be a better.
I hope so.
Better ambassador.
So we are ready. And tell me, do you know the rules? Or it's necessary to remember
yes,
again?
6 minutes will be respected.
Okay. So.
We need to check. Is it work? Does it work?
We have a little technical issues, but it's fine. We quickly will present again. Oh, good, good. So, Share My Space, go for it, and good luck. The floor is yours.
So good afternoon, everyone. My name is Arthur, and I work for Share My Space. So we are a French startup providing orbital data and space situational awareness services to satellite operators and space agencies. So today I'm going to talk to you about MANEX, our maneuver extraction algorithm. So let's start from a strategic standpoint. Why is it interesting to the military to know about space maneuver, and especially for NATO? Today, we are all well aware of the existence of spy satellites and the threat they can represent to assets in space in terms of jamming, eavesdropping, or even one day attacking assets. So our objectives here are to detect and track agile satellites, to confirm hostile activities in space, to anticipate future targets, and to improve space domain understanding overall. So how does our maneuver detection algorithm work today? Basically, it takes time series of orbital parameters to retrieve maneuver from them. So how do we do that? We do that by training an AI from a limited number of known maneuvers, and then we can recognize pattern and extract parameters using signal analysis methods. And today we already have results with this. First, we get specific data about each maneuver, like its date, its duration, or the consumption. So the performance are about 85% in LEO and 95% in GEO. And then we can have aggregate information. So from the history of maneuver of a satellite, we can automatically determine the capacities and the remaining mobility of the satellite. And this is all done using public data only. So for information, MANEX product development has been partly funded by a CNES EUSST research contract with Share My Space. So now that I've explained you how we can already do things today to study maneuvering satellites with public information, let's talk about how to bring maneuver analysis to the next level for the military. So we are talking here about anticipation of maneuvers, visualization of maneuvers, attribution of hostile behavior, meaning that detecting is not enough. You need ways to characterize with certainty that a series of maneuvers is actually hostile. And this all leads to better intelligence and decision-making in the space domain. So once you've extracted the list of maneuvers from a spy satellite, you somehow need to understand what it is trying to do and anticipate the next move. So similar to a radar view commonly used in military systems, we are displaying the maneuvers from the point of view of the strategic assets. So if a satellite shifts its natural orbital trajectory by doing just the right maneuvers to go to your assets, it confirms hostility. And here, an AI can be trained to recognize such patterns, identify potential targets, and trigger a warning when a threat is incoming. However, you still need humans in the loop to process the info, to propose scenarios, and to make decisions. So how can we improve visualization and decision-making overall? Today, the common way to display space informations and space assets is with 3D views. For example, this is the kind of representation we provide to satellite operators to evaluate a risk of collision with a space debris. But 3D has limitation when it comes to maneuvers because we are talking about small shifts of orbital parameters that usually take days or weeks, so it's hard to visualize. And as a space data provider, we are convinced that the way data is displayed is as important as the data itself. This is why we are working with another French startup, EAB Engineering, and their Nucleus VR software to implement a digital twin and virtual reality solution for the space sector. So Nucleus VR environment is basically a virtual situation room when operators can interact around the satellite and display any kind of information and data. When it comes to space domain awareness, this technology could make a big difference. First, it allows to share and display any kind of intelligence and data, and it's designed for remote collaborative work and data exchange, which can be very interesting for organizations like NATO. And it's a customizable tool that works with all the existing AR and VR technologies, so the possibilities are endless. So this makes it ideal for training as well as crisis management. So to conclude, let's come back to the fourth strategic objective of the proposal. We wanted to detect and track agile satellites. That's what we do by extracting space maneuvers. We wanted to anticipate future targets. And as we saw, algorithm could be improved to understand a series of maneuvers and predict a spy satellite next target. We wanted to confirm hostile activities. And that's what we do with comprehensive information and real-time monitoring. And finally, to improve space domain awareness. For the future of military space, we believe VR and digital twins are very well suited to help visualization of threats, intelligence gathering, and decision-making in the space domain. Thank you for your attention.
Thank you. A round of applause for the Share My Space team. Now we move on to the jury questions.
Thank you. Very good presentation. Very nicely done. I'm curious, two things. One, how much regular normal data do you need on a given target to train the AI? And then how much warning can you give someone that this action might be hostile?
So actually, how it works today is that we, like the kind of data we use, even over there, what activities we have. But we use the data from 18 space command, so the TLE and also the SP vectors that we get through commercial agreements with them. And so these data are time series of orbital parameters. So from this time series, we can extract the information. So we can do this afterwards. Like, for example, we have a history of maneuvers from any satellite since the 20 or 30 years. And so this is the data we use to answer the question. And in terms of warning of threats, it's more, yes, if we do the analysis in real time, a series of maneuvers can take weeks. And so once the maneuvers has been detected, the idea is to know in which direction it's coming relatively to potential targets. So once the satellite has deviated from its natural trajectory, the algorithm is able to point finger at possible targets from this.
Thanks.
Have you thought about to train the AI with artificial data, so to get a quicker improvement?
Yes, for the detection of maneuvers, actually, we don't need that because we have actual data, for example, from ESA satellites. They provide us the data of their history of maneuvers.
Okay, then I change the question because when we have time. So somebody is launching a satellite-based debris now. How long, or what is the way that you can get really in-time data, new data?
This is more related to how the US Air Force provides orbit determinations. It will take up to 3 days after launch to have the TLEs and the SP vectors.
One or two questions from France, if possible. The first question that in your example you have given, you were mentioning Sentinel, for example, from ESA, but it's more about station keeping, that maneuver detection of, I would say, underside. So I didn't understand how did you train your AI based only on station keeping, because it's not the final goal.
No, actually it works with, it's not written here, but it works with any kind of maneuvers. So yes, station keeping, but also changes of orbit, changes of altitude, out of orbit maneuvers. And to come back to the question of training the algorithm, it can also be done, yes, with artificial data to train the algorithm. So we don't use only Sentinel. It's an example because we have the complete data set and also the real mass, because this graph shows an estimation of the mass variation of the satellite based on our analysis of maneuvers. So that's just an example to show the capabilities of the algorithm.
Hi, this is Lieutenant Colonel Bennett. Very good presentation. Thank you. One question about determining hostile intent. Because a adversary satellite maneuvers to come close to a friendly satellite, that could be hostile, but it might not be hostile. How do you determine hostile intent from a maneuver?
Like, this is not done entirely automatically. That's why you still need humans in the loop to analyze the situation. But this kind of representation, maybe it's not very clear, but the idea is that you can see what should be the natural trajectory if the satellite didn't maneuver, so just the natural deviation of orbital parameters. And you can see the evolution of its trajectory in the right coordinate system, not just in a 3D. And so you can see actually if the trajectory is shifting towards an asset, and or maybe have an idea of which asset could be the target of this maneuver, because you know it's a spy satellite, but you don't know why it's maneuvering, what it's trying to do. So it gives you indication to visualize the situation in that kind of coordinate system.
Any more questions? No? So thank you, Share My Space, for your interesting presentation. A round of applause for Share My Space. Now, so we will call the next. We will present here in the room. So, Mr. Nikos Bougonikoulou, it's like that? Good. Welcome, Mr. Nikos. Thank you. Tell me, Nikos, it is your first time in Portugal?
No, it's not first time, but it is first time after a period of lockdown of COVID.
Yes, unfortunately. Tell me, what is your expectation for today?
My expectation is very simple, but I like this participation because we have to contribute in an ecosystem of space defense. It's something new and it's interesting for all of us.
Okay, good. And Mr. Nikos, tell me, are you nervous to present?
No, it is, as you know, we are all innovators and we are ready to see new things.
Okay, thank you, Mr. Nikos. So, Aratus team, go for it and good luck. The floor is yours.
Thank you. Our proposal is a intelligent blockchain-enabled space asset protection system. What's the challenge? The challenge is NATO members operating under different or independent space organizations like NASA, ESA, nationals. No coordination strategy for the space forces within the alliance. Alliance space assets are monitored from space ground-based sensors and command control centers. No common system of systems concerning the existing space asset belonging to different member states. Infrastructure, dual use issues. And what is our solution? Data fusion from existing sensors from NATO infrastructure to track and trace all orbital and near Earth space objects. Protection of space missions and allies assets from space debris as well as enemy attacks. Prevention through early warning alerts. Fast and secure transfer of information to command control centers. Synthesis of leading transformation technologies, blockchain, artificial intelligence, and digital twin. Our architecture is with three main components for object detection analysis, threat assessment, alerts, and event log. The one layer is blockchain layer. The second one is artificial intelligence engine, and the vertical space digital twin. The component artificial intelligence engine include knowledge-based process and also argumentation rules component, provide fast and accurate observation via automated processes. The blockchain layer making all information immutable, traceable, and securely distributed. Apply existing surveillance infrastructure for detecting, identifying, and preventing possible collision based on the trajectory position of the moving debris and our asset through the utilization of blockchain layer and artificial intelligence mechanisms. Alliance joint knowledge. Our proposed solution offers capabilities to Alliance swarm nodes to share data to the other nodes, creating a decentralized permission-based database which will allow decision-making policies and a better tracking overview of the numerous space debris. Unique advantages. The combination of artificial intelligence and blockchain will reduce significantly the human error factor. The final system can comprehend with possible incidents or collisions, provide the crisis management option as a final resolution or being depicted through the space digital twin. We propose a complete solution for space defense with integrated novel technologies, blockchain, artificial intelligence, and digital twin. It's not something new. We have already, as company, implemented in civil sector, implemented blockchain and artificial intelligence and digital twin for homeland security to protect and oil and gas pipelines, and also for civil applications for waste management between countries, for example, with blockchain platform. We have example for waste management between Belgium and Netherlands. And the expected impact involves support for a common alliance strategy for the protection of space assets, increased space situational awareness, enhanced decision-making supported by artificial intelligence, and data quality security improvements supported by blockchain. Questions?
Okay, thank you, Mr. Nico. So we next move on to the questions, the jury questions. Please, where is the micro? Quickly, quickly, please. Run. Here.
Not sure why it's always me asking the first question, but I will. I guess. I was going to ask about the maturity of the system. And it sounds like you've already proven it in some ways in other domains, in pipeline security and so on. So now my question is going to be related to that. How much different is the space domain from the domains you're already working in? And how long, how difficult will it be to make that change?
Our proposal is easy to adapt for same reason. We discuss about sensors. For example, for pipeline protection, we use different type of sensors from space, from airborne, and for ground and underground sensors. We do data fusion with the same algorithms, similar like in space. Our proposal will implement using existing data from different sensors and have the advantage of blockchain technology that each member state can share only the part of the information that needed for the system, not to share everything. For this reason, protect our also at operational level national strategies.
And a follow-up quickly, how difficult is it to include new data sets as they come along over the next several years?
It's not difficult because simply in the architecture of system is modular, and from the architecture you can see that we can receive data from different sources, ground or space, and from the other side, using the engine, we can put out in command control center, in one, for example, in NATO, joint forces, or in at national level, member states.
Thank you.
Yeah,
Yeah, just to follow up on that, I'm a bit worried about this data sharing that is a precondition for this. Have you made any thoughts about how or why nations actually should share these data?
Thank you for your question, because maybe it is the new power of blockchain technology. Because with blockchain is similar like when internet coming in mid of 90s, people, especially in defense, but internet starting from defense with DARPA, but believe that it's something that it's not easy to implement. Blockchain give us exactly this opportunity, and already we have many implementation to share data in other sensitive sectors, like governmental bodies for taxes, or banks for money, or for KYC, etc. Then it's simply, we have already resolved the problem earlier in civil domain than in defense. And for this reason, it's not a problem, because already accept at international level.
Thank you. Any more questions? Yes. Online questions?
Yes, a question from France. Thank you for your presentation. I suppose that you are aware of the all kind of data sensor source that we can use to elaborate the space situation, and how will you manage and are you already using AI to manage different types of data, in types, in quantity, and in quality?
Yes. For this reason, our artificial intelligence engine have not only a knowledge base for learning, but also have a recommendation technology component, because in recommendation technology component can put the rules, and for complex systems like in space, for space data from different sensors, using recommendation technology can put different rules and to work better than a very simple artificial intelligence platform.
But have you already used AI solutions?
Yes, already we use for data fusion for data from space, airborne, and ground and underground for pipeline protection.
Thank you.
Sorry. Yes, one more.
In the past, you have worked really with Earth observation data, which is more on the dimensional 3D view. When we speak about orbital data, it's orbital data, yeah? Euler and so on. So, and for AI, that's slightly different. Huh? Have you done something before in that area?
Because we discuss about data and in different models, and for this reason, it's not a problem to have a different. We have already worked with 3D data or others, because it is anything is information, and simply with our system is how to federate different sources of information. For this reason, for example, we can use like other example, other proposal to integrate in this system of systems. The idea is to be open, but from parallel to be secure, and to can give this opportunity to the alliance.
Any questions? Is the last opportunity. Okay, good. Thank you, Mr. Nikos. Round of applause for Nikos and the Aratus team. So, we move on to the next team. And we will then contact the Celestial team and the team leader, Mr. Johan. Celestial team, where are you? Celestial is not there. I think Celestial take a break, and we move on. We move on to the next team. Okay. Celestial team is in the... Okay. So we will wait a little for the Celestial team. And I hope my audience are very, very interested by these subjects. Okay. Celestial team is not ready? Can I jump for the next team? No, I can't.
You have 3 minutes.
3 minutes.
Don't worry, you don't need to entertain the public. You can wait, or they're probably doing something else at the same time too. So
Let's go to commercials.
We're not doing like Hollywood, so we continue on.
Good afternoon. Can you hear me?
Okay. Hello, Celestial team.
Good afternoon. This is
Good
Johannes.
afternoon.
Can you hear me?
Yes, we hear you loud and clear. Hello, Mr. Johanne.
Yes, thank you. Sorry for the delay. I had some trouble with
Okay.
unmuting myself.
Tell me, Mr. Johanne, how are your expectations for today, for this speech?
So the solution that I will be presenting for Celestial is a very specific application of the technology that we are developing. And basically, I'm very much looking forward to the feedback to this solution.
Are you nervous? No?
I'm excited. I'm excited.
Oh, good, great. So, Celestial team, go for it and good luck. The floor is yours.
Okay, thank you very much. I am sharing my screen now, and the presentation should be appearing in front of you right now. If this is not the case, just let me know. So again, good afternoon, everybody. My name is Johannes Schumacher. I'm one of the founders of Celestial. And Celestial has the vision to provide comprehensive intelligence for space domain awareness. So when we look at space, it's becoming increasingly congested with 10,000 satellites planned to be launched during this decade. In addition, there's also at least 12,400 debris particles, which are bigger than 10 centimeters, which are actively being tracked. This number is growing by 1% annually. However, the biggest problem is untracked debris, which is even 70 times denser than the tracked debris. For constellations the size of Starlink, this creates situations with collision probabilities of up to 92% within 1 year. And when we consider the number of satellites in space, the frequency spectrum is also getting increasingly congested. So all of these factors, they threaten space assets, and with that also services used on Earth, such as in banking, communication, navigation, etc., which is putting people and also businesses at risk. However, the threat detection in space is lacking quality and standards. The state-of-the-art space debris tracking and detection technology is ground-based. Most notable is the US Space Surveillance Network, which is a system of radar and optical sensors. Now, radar sensors, they are weather and daylight independent, but they have limited range. Telescopes, on the other hand, have better range, but they're very sensitive to lighting. So radar detection or radar ranging is, or laser ranging rather, is also very sensitive to natural light. So in order for threat detection in order to improve the threat detection in space, the detection technology approaches need to shift from ground-based to space-based approaches. So space-based sensors, they have the benefit of being in proximity to the objects they're supposed to track, which will result in higher accuracy data, basically. So to address this, we are developing a smart antenna tile. Integrating multiple of these tiles will result in a modular phased array antenna. With the appropriate control software, this antenna can be operated as a radar system as well. Now, obviously, this technology is not new, but the application of a space-based radar payload is something new. So in order for this radar payload to successfully detect debris in orbit, it needs to have extensive range and also high sensitivity in order to recognize high velocity passing objects. Now with our tiling approach, it allows for deployment across curved surfaces. And by using RF lenses, we can increase the detection range and sensitivity significantly. So this payload is envisioned to operate in the typical radar modes, which includes the tracking mode, which is basically focusing on specific objects. And it is returning detailed and dedicated data on this object. And also the beam park mode, which is basically focusing detection in a fixed direction and providing statistical data of all passing by objects. With AI-based control, a mixed mode operation can also be achieved to intelligently switch between these modes based on need or request. So this radar payload will have three main detection capabilities. First of all, space debris can be detected. The measurements will basically describe the physical parameters of the detected object, such as orbital parameters, size, and also ballistic coefficient. Second, active spacecrafts or spacecraft characteristics can be determined. So this will allow this can be realized by, for example, identifying thrust capabilities or onboard payloads. So this will basically help by identifying or differentiating between active and passive systems. And third, the frequency spectrum can be monitored. With the data from this payload, a heat map of the frequency utilization can be generated, which helps the satellite operators and constellation operators to identify unauthorized frequency uses and jamming incidences. So this solution is not supposed to be a dedicated constellation. Instead, the radar payload is supposed to be used on as many satellites as possible on different missions. Each satellite which has this payload will be synchronized with a ground-based database and update this database with the data generated. Vice versa, satellites in space can be synchronized with this database and with this also have access to this database. This means with an increasing number of payloads in orbit, the quality of the database and the derived space domain awareness services, such as collision avoidance, will grow. This creates basically a network effect, similar to the navigation capabilities of autonomous cars, who are connected to a map, which is also constantly updated with local traffic data. On the ground side, a control center, or the operators in this control center, can assess the generated data and provide alerts if possible. This includes collision alerts to prepare for orbit correction maneuvers. They are also capable of monitoring specific satellites which seem to be actively jamming other satellites. Further, they can also detect re-entering objects and determine if this is a
Please, you are having muted. Hello?
Yes.
Okay. Sorry, Mr. Johan, but your time finished.
Okay, thank you.
So we move on to the questions of the jury. Please, the micros. Please.
Hello, Eduardo Freire from PT Space. I was wondering about the presentation, very good one, by the way. I was wondering about the type of radar that you will be able to implement, if it is a cooperative, requires cooperative targets, or if it works also with non-cooperative targets. And in this case, what would be the power consumption required for the host satellite?
So the specific technical characteristics have not been worked out yet. I was just about to explain the progress we've made so far, which is we have built an R&D consortium, which is something we are forming right now to design this entire system, which will actually be first demonstrated as a ground station antenna. So after that, we envision to use the same or similar basically upgrade this design for a space grade technology, and also implement the radar functionality. So this entire solution from the technical side has not been worked out yet to this detail that I can answer that. Of course, we have to balance considering the power consumption of the satellites. This is a big concern. We are aware of that. That would be one of the engineering challenges, to make this as low power as possible, and on the other hand, allow for a sufficient detection capability. Probably in the earlier stages, this will be only available for bigger satellites, and then as we will be able to further iterate the technology, hopefully we can also make this available to smaller satellites, which are part of the upcoming mega constellations.
Thank you. We have one more question here in the room, please.
The question will be, what is your plan to be in size, not only power, because you have to know what is acceptable for the market. Do you know what it will be acceptable for the market? Small sats, microsats, nanosats. What is the goal where you want to have in kilograms?
I'm sorry, this was low in volume. I couldn't understand the question.
Okay, when you want to address the market, Johannes, you have to know what is the target you want to achieve. And not see what the market maybe accepts. So what is your goal? Can you tell you in 2 years, we would invest in 2 years, we want to have that system for 200 grams.
So,
I don't know.
As far as I understood, this was a question about the market and the market launch, right? So
Launch, what is the product in terms of kilograms you want to achieve? You have to have a goal where you want to go.
The answer, actually, the question also includes what is the mass of the system that we are targeting, and what is the market and launch window, right? These are the 3 points. Yeah, so maybe I can answer this. So we are targeting the launch of this space segment part of the payload already by the end of 2023, when also there are more satellites in the orbit. And in addition to this, the mass of the system, at present, we are working on the limitations and targeted quantities where we have this small tile, which should be able to deploy and integrate to any kind of satellite as far as our antenna is concerned. The only engineering challenge that we see now is basically with the electronics behind it and the firmware behind it that will do this detection and mod switching as required by the operators. So based on this, the power consumption will be decided and the size will be decided. As far as our antennas and the IP and the innovative approach to this modular antenna is concerned, this is going to be size independent for us. And one tile that we are targeting is just 20 millimeter by 20 millimeter. So we are really targeting with our antenna size or the mass of roughly a few tens of grams per tile. And yeah.
Okay. Can I ask a question? This is Rod Bennett. My first question was about power, but someone asked that already, so I'll just comment on that. I don't think that's an insignificant engineering challenge. Radars are notoriously power hungry, and to do this in such a small form factor and get some good utility out of it will be an interesting challenge. But my question is more on the data that you're going to ingest from multiple sources, since you intend to fly this payload on as many host satellites as possible. How will you correct errors, resolve conflicting observations, and generally ensure the data in the database is accurate enough to make operational decisions?
Yeah, so the data operations or data processing will most likely all happen on ground because also of power requirements and memory requirements. And this will be, for this, we will require another partner. So Celestial, basically, we are focusing on antenna development or the development of this system. And we are, in parallel, we are talking to companies who are already providing space domain, space situational awareness services. So we are verifying with them the utility of the data that we intend to generate, as I mentioned during the presentation for debris, for example. And these companies are also an envisioned future partner to develop this database.
Joanna, are you hearing? The time is over. We must continue. Thank you for answering the questions, and thank you for your excellent presentation. So a round of applause for Celestial team. So right away we move on to the next presentation that will be run with its Synthetic Spaces Future team. And the team leader will be Miss Mirna. Hi, Mirna. Please, Mirna. Mirna, are you hearing us?
Yes, hello.
Hello, Mirna. How
are you?
I'm fine, thanks. And you?
I'm fantastic.
Great. Tell me, Mirna, what are your expectations for today for this pitch?
We're really excited to share what we have been up to and to hear the questions and feedback and understand our context in the domain of space.
Okay, share with us, Mirna. Are you nervous?
Oh, absolutely, always, but I call it enthusiasm.
Okay, great, Mirna. So, run with it, Synthetic Spaces Future. Go for it, and good luck. The floor is yours, Mirna.
Thank you so much for the opportunity to share our challenge entry, Synthetic Space. My name is Myrna Bittner, and I am the CEO and co-founder of Run With It Synthetics. And this is a company I started in 2014 with Dean Bittner, our CTO, to address system complexity and risk. Run With It's synthetic modeling platform builds AI-based realities around global systems for strategic decision support. And for the past 7 years, we've applied our advanced modeling and visualization tech to reimagining satellite communications and media, transportation and mobility, energy transition and resilience, mission readiness, and critical operations.
Your audio's doubled up.
Is there an issue with my audio?
Mirna, we are listening to you.
Okay. Our clients explore limitless what-if scenarios to inform their choices around design, mitigation, and risk. The models generate the emergent behavior data they need to calculate complex ripple and knock-on effects from unprecedented futures, including human impacts. This short movie will describe more of what we have planned for synthetic space.
Myrna, we can't hear you anymore.
Run With It Synthetic Space offers a living, collaborative future lab to connect, design, and inform space preparations, mitigations, and response, ensuring the safety and security of NATO members from disruptions on Earth and in space. Run With It's environments are currently at work helping cities, utilities, communications, and technology companies solve strategic complex challenges. Using our synthetics platform of interconnected models and bespoke models, we can rapidly furnish live, hyper-localized, geospatially accurate regions with all of their activity. These models are complete with a region's people, their lives and livelihoods, technologies, supply chains, infrastructure, and policies. We call these comprehensive future labs single synthetic environments. In a single synthetic environment, we specialize in de-siloing the interconnected dependencies and vulnerabilities of these systems. In one holistic place, we inform risk mitigation, investment, and resilience impact decisions for systems facing the potential of novel events and scenarios. Scenarios can include high-impact, low-frequency events or longer-term shifts such as those caused by knock-on effects or climate change. Run with It projects involve complex, multivariate, non-deterministic problems and solutions, and often this means not only the inclusion of technologies and systems, but also their intersections with people. Our synthetic people have unprecedented realism, including the capability to sense, respond, plan, learn, and adapt. Models of economic and environmental systems interact with these people and allow us to gain valuable data around any changes in safety and security. Adding and connecting models of technologies like satellites and how damaging events impact satellites will further inform the resilience of terrestrial systems. Cause and effect of failure ripples through these connected systems in a single synthetic environment. Events that disable satellites like space debris, collisions, solar storms, even hostile attacks can cause impacts back on Earth. In a synthetic environment, we can make a microsecond error that occurred when a GPS satellite was being taken offline disrupted GPS-dependent timing systems around the world for more than 12 hours, impacting networks, energy systems, disrupting radio broadcasts, and setting off thousands of escalating system alarms. Accurate time measurements control the flow of data through networks, and while this particular error was solved in a relatively short amount of time with the help of various backup timing systems, it's an example of how the loss of GPS satellites, even the smallest unintentional disruption, can trigger profound and disparate impacts. What may be considered a minor disruption for one nation, in another nation may put millions of people at risk by bringing down a flood detection or alert system, jeopardizing early warning and evacuation. And potential for disruption of all kinds increases with the mega constellations additions of Starlink and OnWeb to crowded Earth orbits. Synthetic Space Futures furnishes a compelling, quantified way of exploring these vulnerabilities with stakeholders and members, building support for targeted future resilience and mitigation investments. By adding space to Run with Its synthetic futures, the result is a living laboratory that enables a complete safety and security strategy environment for connected systems. The capability to manage threat surfaces in orbit and trial resilience back on Earth. Run with Its synthetic space, a synthetic twin platform for designing and optimizing space for our sustainable, secure, and resilient futures.
So really, the goal of synthetic space is to arrive at shared priorities around optimal resilient strategies for NATO members. Run with It is going to extend our synthetic models, adding space services to our existing extensive model catalog, using our process of incorporating the latest research, data from public and other systems, and domain expertise. Run with It has experience delivering value doing exactly this for the past 7 years. And we really believe that Run with It synthetic space can help design a safer, more secure, and resilient future.
Mirna, please. The time is over. Thank you for your amazing presentation. Now we move on to the questions of the jury present here in the room. So any questions?
Good afternoon. Thank you for your presentation. I would like to know a little bit more about the level of maturity of your solution. And if you can share with us any kind of scenario that you have been working with this solution. Thank you.
Certainly. So thank you for the question. We have been creating synthetic realities for the past 7.5 years. Some of our largest clients include telecommunications industry and digital media. But recently we have moved into energy systems, energy grids, mobility systems, and resilience environments. So we are commercial, but we are looking and always extending our modeling catalog to include new verticals because the world's interconnections just don't seem to end. We've also done joint bid projects for the US Air Force with the Electric Power Research Institute just this past year.
Thank you, Mirna. online. So we move on to the French Space Force, please.
Yes, French Space Command, thank you for your presentation. How do you fuse heterogeneous info and data from different sources, and which methods do you intend to elaborate space defense strategies?
I'll maybe begin answering that question, and then we also have Dean Bittner, the CTO, here online, as well as Sama. So really, our process is almost entirely reliant currently on public sources of data. And the reason why I say that is because we pull in a vast amount of data. So data from historical sources, but it's often incomplete or biased. And so we look to inform our models as a beginning place with that historical data, but then we also look for sources of domain expertise, research, and we use those in a process to inform each one of these models that are then interconnected in these environments. And everything is explainable and manipulatable. So research and experts can collaborate in these environments as well to make sure that the models are representing the interrelationships the way they see them. And Dean, would you care to add anything to that comment?
Thank you, Mirna. So no more further questions?
I have one question here on the French side. I'm asking myself, how do you integrate uncertainty on your model? Do you consider that the interactions that you are considering are by definition perfect, or do you integrate the sensitivity and the uncertainty which exists by nature?
Yes, so to answer your question, it's extraordinarily challenging to model novel scenarios, so the unprecedented. And so that's why we build very complex interconnected models, but each one basically breaks down into a representative and understandable piece. We use all different techniques of creating ranges of behavior according to, historical information, according to what domain experts believe will happen. And then we begin to interconnect, and it's a process of validation as we go through these projects with our customers to really understand whether or not they're seeing what they believe would be the relationships and the interconnections. And then once we go through this process of validity, we can really explore a whole range of what ifs. So we call them knobs and levers. So we enable people to change and manipulate and work with the environment to really characterize a broad scope of the imagined and unimagined futures. But yes, we have a lot of experience with emergent behavior and helping people achieve certainty with different levels of fidelity and what they need to see for that emergent behavior.
Thanks. I've got one last question. We seem to have 1 minute and 9 seconds left, so I'll be quick. Clearly, this is for a strategic level. So, as you said, shared priorities. Do you imagine this becoming a much more tactical tool someday? And how would that happen?
Oh, absolutely. So I put up here kind of how we are currently working, and we are very tactical in some environments that we have had, for example, 7 years in the digital communications systems sector. And in that sector, we work with very highly technical expert teams, and we supply the environments, and they utilize them for their own analysis in ways that we aren't even privy to. So, it has become very tactical for them. But usually the starting place is in really executive level, strategic kind of decision support, as well as stakeholder engagement. So when there's very complex issues that people are trying to help a group see forward and into and understand, for example, resilience investments, that's usually more along the lines of a full service, we call it single synthetic environment, where we work with the organization to create the environment and then we deliver the results.
Mirna, I'm so sorry, but the time is over. Thank you, Mirna. and a round of applause for Run With It Synthetic Future Spaces. So thank you for the first 5 teams and for their amazing presentations. I guess that it will be hard work for the members of the jury choose the first 3 places. It's now time to have a short break so that our physical guests and the online ones can replenish their energies and can prepare themselves for the second part of this journey. So we'll see each other in 25 minutes. Can I ask to the next team, Avalon Holographics, to log in at least 5 minutes before the start time. See you soon.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet, and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem, and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, Space Safety and Security Applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive, the Sun. Violent solar activity, such as flares and coronal mass ejections, can damage satellites, disrupt communications and knock out power grids. An extreme solar storm could cause €15 billion worth of economic damage in Europe alone. ESA is working on Lagrange, a mission to a unique point in space known as L5. By taking a side view of the Sun, the Lagrange mission will monitor solar activity and warn us of any impending risks. The third threat is space debris, a growing concern that places our vital satellites and daily services they provide at risk. There are more than 900,000 pieces of debris in orbit with a size larger than 1 centimetre. Any impact with a functioning satellite could mean end of mission. Several companies are beginning deployments of large constellations of satellites, and ESA must develop an automated collision avoidance system in order to protect spacecraft in these busy space highways, as the current manual avoidance processes will be overwhelmed. New in-orbit servicing technologies would demonstrate that Europe can remove space junk from orbit. Closer to home, another ESA project will increase safety in the skies. ESA's IRIS partnership will provide improved, secure data links between aircraft and air traffic control using satellites. It will improve air traffic management, saving fuel and easing congestion. ESA is also working to boost cybersecurity, not only within the agency but across Europe's space sector, helping make spaceflight more resilient to attack and accelerating the integration of space systems and services on the ground. By protecting our infrastructure on Earth and in space, ESA is safeguarding the assets that will secure Europe's economic future.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet, and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem, and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, Space Safety and Security Applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive, the Sun. Violent solar activity, such as flares and coronal mass ejections, can damage satellites, disrupt communications and knock out power grids. An extreme solar storm could cause €15 billion worth of economic damage in Europe alone. ESA is working on Lagrange, a mission to a unique point in space known as L5. By taking a side view of the Sun, the Lagrange mission will monitor solar activity and warn us of any impending risks. The third threat is space debris, a growing concern that places our vital satellites and daily services they provide at risk. There are more than 900,000 pieces of debris in orbit with a size larger than 1 centimetre. Any impact with a functioning satellite could mean end of mission. Several companies are beginning deployments of large constellations of satellites, and ESA must develop an automated collision avoidance system in order to protect spacecraft in these busy space highways, as the current manual avoidance processes will be overwhelmed. New in-orbit servicing technologies would demonstrate that Europe can remove space junk from orbit. Closer to home, another ESA project will increase safety in the skies. ESA's IRIS partnership will provide improved, secure data links between aircraft and air traffic control using
Ladies and
satellites.
gentlemen, please, may I have your attention? I kindly ask you to take your seats, please, and remind you that the use of face masks is mandatory, and don't forget to silence your phones during the entire event. Thank you. Ladies and gentlemen, please your attention. We need to continue. Please take your seats. So, We are back again for the second part of the presentations. I hope that you have enjoyed the Portuguese coffee and that you have the energies Beck requires to continue with this speech in a dynamic and enjoyable way. So, we will contact again the next team who will be present. It will be Avalon Holographics team and the team leader, Dana Brewer.
Russ Baker is supposed to be the presenter for Avalon Holographics. I believe he's in a breakout room.
Hello, Dana.
Hello.
Hello, Dana. How are you?
I'm good. How are you?
I'm fine, thanks. Dana, tell me.
It looks like Russ has the keys now.
Sorry?
It looks like Russ has the keys now with his presentation.
I don't understand your question, Dana. Sorry.
I'm not the presenter. Russ Baker is.
You're not. Who will be present?
Russ Baker.
Cross Baker. Sorry. Thank you.
No problem.
Tell us what are your expectations for today?
Hi there. Yes, this is Russ. Can you hear me?
Hello, Russ. How are you? Can you hear me, Russ? Hello, Russ. Sorry, we lost the connection. We will try again to connect the Avalon Holographics.
Hello.
Russ is back, but he's muted. There we go.
Hello,
There we go.
Russ.
Somebody threw me into a breakout room. Sorry about that.
No, it's okay, Russ. Tell us, Russ, what is your expectations for today?
My hope is that everyone can come away with a better understanding of holographic displays, what it is we do at Avalon, and how that might be used for space situational awareness, and to see if I can learn more about how NATO is tackling these sorts of technologies.
Okay, share with us. Are you nervous?
Nope.
Oh, great. We have a brave man.
Okay. I do a bunch of these, so no, not a problem.
Okay, so Avalon Holographics. Go
Perfect.
for it and good luck. The floor is yours.
Perfect, thank you. So first of all, a quick introduction. We are Avalon Holographics. We're a Canadian company making professional holographic displays. Founded in 2015, we have a fairly large team spread across Canada, founded by myself and a guy named Wally Haas. We have some previous exits in the tech space, so we're familiar with how to launch new technologies. What we're actually building, what we're actually building is professional holographic display technology. This is designed to really solve the 3D problem properly for the first time. And then the idea here is you would have no accessories. In other words, you wouldn't have to wear anything, no eye tracking, and no side effects due to things like nausea and fatigue. The idea is this would behave like a window into the world, and the 3D objects would behave as you would expect to see them. So the thing we usually start with is what isn't a holographic display. There's a lot of confusion about that term in the market. First of all, anything based on stereo 3D is not holographic, and that's most technologies that are out there. The most advanced ones today use something known as half parallax, super stereoscopic, but that is still a stereo technology. And the key is these are all tricks. And what they're not doing is presenting your eyes with directional rays of light to focus on, which means you cannot focus on real object images, which in turn means you won't perceive them as natural 3D objects. The other thing I'll quickly note is we are also not doing anything you've seen in movies with floating light in the room. It is an actual display. So what we are working on, as I said, is a display that generates directional rays of light. If you generate directional rays of light from a screen, there's no real way for your eyes to tell the difference between the fact that it came from a screen or from real objects in the world. And that is the way that our human visual system evolved to see the world. So you can't break the frame of the display. The scene from Prometheus is a good example. All of that light is coming from the surface of the display. There's depth into the table. There is depth coming up above the table, but there is not anything that goes outside of the boundaries from this camera angle. Of course, in the movie, there's floating light in the scene, and that chunk of floating light that's shown there would be not visible from this camera angle in a real display. So beyond the cool and wow factor of that, what's most important is that light fields are what human beings evolved to look at, and all holograms are light fields. So if you only remember two things today, the first is that holographic displays will reduce cognitive load pretty dramatically, 50% or more, and that they're very comfortable. So you won't have to wear anything, you won't have any side effects the way that you do with existing 3D technologies. I'm going to talk a little bit about markets and use cases now. Our first main markets are defense, medical, and space. Defense and space are very closely aligned for 3D visualization. And the reason is that all of the data in these spaces is inherently three-dimensional. Nobody really wants to be wearing any form of headgear. That's just a convenient way to deliver the current technology. These all involve long-term use, like all day through an entire shift for an operator. You can't just sit and use them for 10 or 15 minutes. And most importantly, in terms of how they're used, there's a lot of commonality and the importance of things like making real-time decisions. High consequence, high-speed decision-making is a huge factor for most of these applications. Big data analysis, modeling and simulation, and of course, anytime you're dealing with group communication, particularly with non-experts, these are all things that are very useful in terms of situational awareness in space. Now, in terms of benefits, the bottom line is cognitive benefit is the key to all of this. Anywhere from 20 to over 50% cognitive improvement using holograms has already been proven with still print holograms, and that leads to faster, better decision-making, faster learning and better retention, and more alertness and stamina because you don't have side effects that are fatiguing you. And importantly, not only is this applicable to spatial information, but it is also applicable to non-spatial data. So when it comes to space situational awareness, there's actually been work done in the US by the Air Force Research Lab in relation to JSPOC that says that full parallax 3D visualization is critical for many of these use cases. Conjunction assessment and collision avoidance come up very regularly. Visualization of resonant space objects and just determining whether they're suspicious and what to do about them. And I have a great quote from a NORAD commander that we know here locally that said, orbital mechanics aren't intuitive, but more importantly, trying to present on this topic is often a very, very challenging idea, let's put it that way. And throughout any of our engagement with the market, we always hear that 3D visualization is very important for communication with non-experts and decision makers. I'll touch briefly on how the system works without getting into a lot of detail. The bottom line is we're designed to run on a normal compute system with GPUs, and we have ports to Unreal Engine and Unity and an application called SIMDIS, as well as an SDK for direct integration into existing applications. So this is a simple visualization of what our current prototype looks like. You can see as the camera moves here, you get natural parallax shift in both dimensions. And the idea is that would be like an operator console. This is how it might look for a space visualization application. We also have a next-gen platform coming out called Maxwell, which is a tabletop, much higher fidelity and a little bit bigger, more like a 50-inch diagonal. And we're seeing a lot of interest in that from the defense community. And again, you can see what that would look like in a space situational awareness application. And that's it in summary. We see this as the next big thing in displays. We're calling it displayed reality, and I hope you enjoy it. Thank you.
Thank you, Russ, for your comprehensive presentation. Now we move on to the questions of the jury. I ask to the team if we have any online questions. No? So I pass for the jury present in the room.
They always leave it up to me. I don't know why. Russ, good presentation. I don't know if you know this, but we couldn't see your charts.
Oh.
Yeah, but don't worry about it. I think most of us have probably seen some of these things and generally get the point of it. But to that question though, I always ask this question. I never really get a good answer to it. But describe to me more about the evidence that's out there that using this kind of visualization reduces cognitive load, makes better decisions, is easier to visualize, is easier to explain why orbital mechanics is difficult, which, by the way, I've taken 3 times and still don't quite understand. So give me some more data on what the proof of that is.
Sure. So there's some studies that were done back maybe about 15 years ago on still print holograms, which are sort of the origin of all this technology, laser interference-based holograms. And in those studies, I can actually, if there's a follow-up contact, I can send those out, links to them. They're available publicly. And they studied this really in 3 different contexts. 2 of the studies were done on mission planning for special forces and SWAT teams. So in one case, the SWAT teams were doing route plans through a building, and they were using three-dimensional diagrams, just printed on 2D or on a 2D screen. Relative to the actual printed holograms. And in the case of the special forces, that they actually started using holograms for missions in Afghanistan because they needed to plan routes through steep canyons and figure out, okay, when am I going to come in someone else's sight line, for example. And then the 3rd study was done on medical training, so it was more anatomy training, and then that was more about learning and retention, as opposed to the other 2 studies showed the cognitive performance and resulting in higher quality decisions made faster. We've also done some beginning to do some studies of our own. They're mostly qualitative at this stage because we haven't had the funding to do a proper human factor study, but we hope to prove that out on our displays as well.
We have one online question from Kevin Rivers from NASA Head of Innovation. Please.
Thank you, Russ. So I'm curious. I think this is an amazing technology, by the way, and really actually enjoyed your response to the last question. But I'm curious to know how, are you guys just supplying this display capability, or are you proposing to do some data fusion to capitalize on this display capability? Because I'm just wondering if you've thought about, and not just here's a great way to look at information, but how are you pulling information into to show it to as part of your proposal?
Yeah, so the honest answer is we are not domain experts in this domain or in some of the other domains either. So the goal is to provide a visualization platform to integrate the data that already exists in other platforms. So even some of the stuff that's been presented earlier today. We're trying to make the tools available so that that's an easy process. We found gaming engines are one easy example of that, where there's lots and lots of ecosystem support for moving data, especially some GIS type spatial data around within those platforms. Existing platforms can also be adapted using our SDK to present data on the displays. And depending on the performance requirements, that can range from a very trivially simple exercise to a more involved integration process. Yeah, so I'm going to try throwing my screen back up. It showed me, as far as my system was concerned, it was up, so I apologize for that. Are you not seeing it still?
I can see. Okay. Yes.
It is up. Okay. Yeah, so I can hopefully these will be available. I can send these to be provided after the fact. But possibly the most interesting visual is probably this one. This is our current prototype. This is a rendering of our current prototype. This stuff is notorious for not filming well on 2D, unfortunately.
We have, sorry.
Russ, we have 1 minute left. When this is the prototype max, what is the prototype max in 3 years?
Yes, so the Proto Max here is out now, but next year, actually, this if you're seeing it, Maxwell is our tabletop version. It doesn't have to be mounted as a tabletop. That just happens to be the most common interest from our main customer base. And that's coming out. It'll be in our lab by the back half of next year, probably being sold in 2023.
So we move on to the next question from the French space. Please. French space command, please. You have the floor.
Yeah. So sorry, we had an issue with the computer. Thank you for the presentation. Very impressive. You mentioned that you don't have any a specific space expertise, but based on your innovative proposal, did you try to? Do you? I think. Do you think that you will face a lot of constraints to modelize the space? Because if you want to have a cognitive benefits, it's not the same story to visualize in LEO and then in just stationary orbit. Did you think about it?
Yes, so we have had many conversations with various groups here in Canada and in the US primarily at this point on the topic. So we're at least familiar with, both the interest in the technology, but also, potential challenges of adoption. This is true in most domains where you've got, highly trained specialists that have already learned how to do what they do very efficiently in a specific way now. So we don't expect it to be an immediate process, but what we hope is that as the technology becomes available and people see the benefits, there will be early adopters in each of our main spaces, when we already have some of those in, especially in defense, who see the value and therefore will sort of take the plunge and begin the process. But we do expect it to be we don't anticipate this suddenly being everywhere within the next year, say.
Thank you, Russ. Thank you for answering all the questions. So a round of applause for Avalon Holographics, please. So right away, we move on to the next presentation. And I will contact the mission space team and the team leader, Mr. Alex Poshpikov.
Hello, everyone.
Alex.
Hello, everyone. Yes, the Ksenia Moskalenko will present everything now.
How are you, Alex?
Great. Can you hear me?
Yes, we hear you loud and clear.
Yeah.
Tell me, Alex, you are ready to start?
Yeah. Would present everything.
Alex, can you hear us? Okay, we will try again to connect. Alex.
Hi, everyone. So it's not me who's going to present. It's Ksenia Moskalenko. She was also on the trials and nobody let her unmute herself. Please, could the host unmute Ksenia? I'm not sure why am I being unmuted.
Hi, yes, finally.
I'm talking with, please.
Hi, I'm Ksenia. I'm the CEO and co-founder of Midnight.
How are you?
I'm good. I'm good.
You present your idea from Mission Space?
Yes,
okay.
yes.
And tell us how are your expectations for today?
So we're just super grateful and excited for this opportunity to present to such experts, and we would love to hear the questions and the feedback. That's just a great opportunity for us.
And tell me, are you ready?
Ready, absolutely, super excited.
Okay, so Mission Space, go for it and good luck. The floor is yours.
Thank you. Okay, perfect. Hi, everyone. My name is Ksenia. I'm the CEO and co-founder of Mission Space, and we're presenting a satellite-based space weather prediction system. So space weather as a phenomena ranks among the highest priority natural hazards. There are three types of events: the geomagnetic storms, solar radiation storms, and radio blackouts that have the ability to affect the most critical technologies and cause disruptions both in space and on the ground. So why does NATO care about space weather? Space weather threat has the potential to affect the alliance's safety, security, and interests. For example, the process of scintillation, which is a cause of space weather, leads to degraded satellite communications and all types of GPS errors in positioning, navigation, and timing. Solar flares are responsible for satellite orbit decay, geolocation errors, radar interference, and high-frequency radio blackouts. And last but not least, the geomagnetic storms are also responsible for space track errors, radio propagation anomalies, and power grid failures. In terms of the current space weather solutions, there are only 4 space weather satellites that are operating well beyond their anticipated lifespans and unfortunately are expected to fail before the replacement is launched. Also, the ground observatories, they measure space weather events, but only after they already took place. For example, also there was a case with Discover recently, which is one of the current space weather satellites. It was put into safe hold mode for 9 months in 2019, and it didn't transmit any data. And for such alliances like NATO, that's a problem. When existing space weather satellites fail, we will have no space weather coverage at all. Thus said, there is a need to establish a coordinated monitoring of ionosphere to predict the propagation of waves and timely warn NATO of any irregularities. Also, we see this as an opportunity to act now because in 2019, NATO and the US Department of Defense signed a space weather strategy and action plan that aims to update the current aging and limited observing systems and start utilizing commercial data sources. And also just this month, NATO and Luxembourg signed a strategic space situational awareness system that has the goals of improving the understanding of space objects and space events, where space weather plays one of the key roles. So what ultimately we're building is a global predictive space weather system that is designed to be used as a decision support tool to detect, predict, and warn about space weather events, provide timely regional forecasts and effects to the use of radio communication and GPS. In terms of our composition, we have our own NATO satellites equipped with custom payload, as well as a software with space weather data and hazard warning system. We build and launch our own NATO satellites that monitor space weather conditions from low Earth orbit. And on the picture to your right, you can see our Mission Space 1, which is a CubeSat that will be launched to LEO in February of 2022. A little bit more about our payload. Our technical team has developed 2 detectors that form the basis of our space weather prediction system. And those detectors measure the geophysical data, high energy particles of protons and electrons, radiation environment fluxes, ionospheric forecasting and nowcasting, and the geomagnetic index. Also, we plan to have around the globe forecast system with the 24 nanosatellites on LEO with galactic ray detectors on each board. And this unique system will allow us to have a real-time high-energy particle geophysics data and a real-time prediction of solar plasma arrival and intensity. In terms of our operation, so Mission Space collects data from space in real times, transform it into predictive analytics, value-added insights, and alert notifications. So our satellites gather critical space weather data, then the payload data from satellites is transmitted to the ground stations for further analysis, and then the raw data is converted to smart data, the value-added algorithms are added, and the data can be used by NATO. In terms of our competitive advantage, we're competing with the 4 legacy satellites that are operating out of their warranty period and cost millions of dollars to make. In terms of our solution, we will have 24 nanosatellites with an unlimited and uninterruptible working mode during operation. They will be launched in 2022. They're 10 times less expensive in production than the existing systems and have the backup and have the backup capability of existing systems in case of failure, like the Discover one. In terms of why does NATO need us? So our predictive space weather system can give advanced notice of hazard events that could disrupt allies' ability to share information, increase interoperability, and coordinate action. We will allow to facilitate early warnings for destructive space weather events, will be able to contribute to increasing the space weather and space situation awareness of space weather at all levels of military leadership, planning, and execution, will be able to contribute to environmental monitoring, to enable meteorological forecasting and mission planning, and of course, secure satellite communications, which are essential for missions to enable consultation, command, and control. We're heavily supported by the leading European institutions and have received commercial interest from several organizations all across the world. In terms of our roadmap, we have the satellite build. We're currently at the final stages of payload and satellite integration. We already launched our payload into the stratosphere. It was a successful pre-orbit demonstration. In early 22, we'll have our system demonstration operational environment, and of course, the final launch of the first stage of our system and our first pilot programs. Thank you so much. For us, Earth is only a start, and we're open to any questions. Thank you.
Hello, amazing presentation. Thank you, Mission Space team. Then we will move on right away for the questions. Please, you have a question? No?
Yes. Yeah, very impressive. You're launching in 2022. I'm curious about two things. One, how have you been funded so far? And what do you need from NATO to go forward?
Okay, so I guess it will be me on behalf of our team. So yes, we're currently self-funded and we're in the process of our seed round stage. For the launch of our satellite, the first satellite will need, I think, 300,000 euros to just complete the final launch and receive the first data to our ground stations.
Thank you. I asked to Jerry if you have more questions. No? So thank you for answer the questions. And you have one more, please.
If we have time, I've got nowhere to be. The obvious question is, why hasn't this been done before? This is clearly an important issue, and the 5 satellites that are up there decaying rapidly are a problem. Why hasn't this happened already?
Yeah, I would be gladly answer it. So the answer is that the question is why Elon Musk launched the private rockets for the small size of the budget that usually space agencies spend, because, well, first of all, we're just like private company and we tend to do everything faster, cheaper, and more efficient. The next question that is very special focus, and maybe there are, I don't know, like 500 people or 1,000 people all around the Earth that are working in the space radiation domain. So here's the answer. We're just the first.
Okay. Yes, of course, please.
I just wonder whether you could drill a bit more into this funding. Now we saw a lot of sponsors on the last slide, but how does that actually work, and where do you see NATO's role since you're pitching to us?
Yes, sure. We know that NATO already some companies, and we know it's very, very complicated to organize commercial cooperation with space agencies and structures like NATO. So we would like to know how to start the whole process, because technically we're not selling the final product to the customers. So we have different verticals for customers, for example, like airlines or international regulators. And for them, we are providing different kind of the products. For example, they would like us to make custom models or custom software services. So what we like to know is, we know that we have data that's very useful for military use. At this point, we would like to see what the final product could be.
Thank you. And a round of applause for Mission Space, of course. So we will contact then the next team, that will be Norse team. Okay, so we have online the Norse team.
Good afternoon. Can you hear me okay?
Yes, loud and clear. Good afternoon. I'm speaking with, please.
Hi, you're speaking with Dins, Ralph Dinsley.
Okay, tell me, what are your expectations for today?
Well, so far our expectations have been met by watching some wonderful presentations from other participating companies in this event, and hopefully our pitch will be equally as good or more innovative than our competitors.
Okay, and tell me, are you ready to start?
I am. If I can just confirm that my colleague Lawrence can also speak, if that's okay.
If you can hear me, then yes, I can speak.
Excellent. Yes, can hear you loud and clear.
Loud and clear. Okay, so Team Norse, go for it and good luck. The floor
Thank you very much.
Yours.
Good afternoon, everybody, and thank you for this wonderful opportunity to present to you. I'm Ralph Dinsley, and I'm the founder and executive director of Northern Space and Security Limited, known as Norse. And presenting with me is my colleague, Lawrence Blacketer, who is the Norse senior scientist. Norse is the UK's leading commercial end-to-end provider of space situational awareness capabilities dedicated to space sustainability and empowering terrestrial success through understanding opportunities in outer space. Put simply, we generate data and awareness of space to help the growth of businesses utilising data from space, and we support governments to regulate space. Our unique selling point is the unprecedented military, civil and commercial and academic experience that we have fused across the company to support governments and industry. Furthermore, we are dedicated to the development of experience for the long-term utilisation of space, and we employ a young, growing team to ensure support to future informed space operations. Space domain awareness cannot be achieved through the use of just one source of data or information, and our proposal uses the measurement of object brightness against time for object characterization, fused with broader orbital analysis, understanding, and more complete space awareness picture. In short, it adds significant value to the space domain awareness in order to characterize the existing properties of resident space objects and highlight any changes in the object pattern of life. All yours, Lawrence.
Yes, there we go. I was struggling to unmute. So the area that we have identified that can provide novel space domain awareness capabilities is light curve analysis. Although light curve analysis of space objects is currently at a low TRL, the concept has already been proven and de-risked in academia. It is therefore presents a unique opportunity as it can be quickly developed from an area of innovation into an operational capability, both quickly and with a high likelihood of success. This slide in front of you gives a rough overview of the technical implementation of light curve analysis. The approach is a two-pronged attack of anomaly detection and light curve simulation. The box on the left shows some examples of anomaly detection. The basic concept is that examining an object's light signature provides a pattern of life for that object. A departure from this pattern of life is an indication that the object has performed an action. However, this kind of analysis only tells you that an action has been performed. It doesn't tell you what the action was. This is where light curve simulation comes in. A synthetic light curve model will produce a synthetic light curve signature for that object based on assumptions of its size and shape, etc. This simulation model allows you to determine actions that the space object may have performed that resulted in the anomaly that was detected. This technique makes it possible to determine space situational awareness information that was previously unavailable. This includes changes in behavior, changes in attitude state, changes in configuration, and unnatural changes in motion that may otherwise have been hidden. Next slide, please. So an advantage that light curve analysis has is that it works synergistically with existing space domain awareness capabilities. All of the existing pathways of space domain awareness information that have been used historically are taken into account and fed into the light curve analysis. This is therefore a maximum value solution. It builds upon and augments present day capabilities. Next slide, please. So as we all know, information is only as good as how easily and efficiently it can be communicated to others. This is something that Norse have valued very highly, and it's why we have spent a lot of time and effort developing our NorseTrack software. The entire purpose of NorseTrack is to perform orbital analysis and generate visualizations that enable the results of this analysis to be communicated to and understood by others, regardless of their experience in the topic. Half of the work of our proposed solution has therefore already been achieved. This means that all of our time can be focused on the implementation of the light curve analysis capability. Hence, this proposed solution will provide a new avenue of information on space object behavior and intent with a high likelihood of success and with a very short path to implementation. And with that, I'll pass it back to Dins.
Resident space object characterization through light curve analysis adds a significant tool to the wide space domain awareness toolbox. It not only provides a passive capability for assessing an object on orbit, but ultimately adds another layer of understanding to the protect and defend operational needs of NATO, both in space and in supporting terrestrial operators. Thank you for your time, and we're open for questions.
Thank you, Norse. Thank you for the comprehensive presentation. Now we move on to the questions of the jury. Please. We have one question.
Yeah, thank you very much for the presentation. I just I saw in what you sent ahead that it was highly cost effective. I wonder whether you could qualify that somehow to better understand that.
Yeah, I'll take that one for the moment. So we've developed a LEO tracking system known as Loki, our LEO optical camera installation, which is in an order of magnitude a lot cheaper than obviously radar. And it's the additional capability of analyzing the light curves that we collect through Loki that actually makes this cost effective. So it's a system that effectively has been created to track objects, but this is an additional benefit from that light information that we collect from our system.
We have one more question from our online jury from French Space Command, please.
Yeah, very nice presentation. I have a question on the, to estimate, to reconstruct the altitude from low-resolute data, you need to several steps, the modeling of the light curves, in this case, the modeling of the attitude, the estimation of the attitude. And then my question is, where are you today on these different modules, on the modeling of the light curves, on the solving of the inverse problem, and so on? And my second question will be, which is the level of fidelity that you need from the satellite in order to solve the inverse problem? Do you need to know the shape roughly? Do you need to know the shape precisely? And so on. So would you comment on that, please?
Lawrence, are you okay with that one?
Did you
He's
understand?
struggling to unmute.
Yeah, sorry, I don't have control over my own abilities to unmute, so I was just patiently waiting. So yeah, to the first question, as I mentioned, this is work that has already been done, or at least proven in concept in academia, in part by myself. Everything that we've said we've done before, this is the progressing it into a fully operationalized capability. In that degree, we're pretty far down the line. And to your second question, which is a good one, the level of fidelity you need in the model, in part depends on the questions you want to answer. Although the research has shown very promisingly that you can get really quite good solutions with very coarse models. So for example, you can model sort of generic box wing spacecraft with nothing more than 3 box-shaped objects, 2 for the solar panels, 1 for the central bus, attached together and get good results from that. Same for rocket bodies. You can get really good results from just a cylinder. So we're really not constrained by needing really high fidelity models of the objects that we're trying to analyze.
Okay, thank you for that. A similar question, I think, or a related question is, how easy would it be for a hostile actor to spoof or fool the model?
Yeah, that's another good question. It's in fact actually one of the things that we're most interested in overcoming. An example that we've looked at is an object that will intentionally induce tumble. So you look at this object with sort of more traditional techniques, and you see an oscillating signal that you very quickly just identify as, oh, it's a tumbling object. I don't need to look at it any further. We can actually use these models to look for hidden signals inside this spoofed signal that are departures from natural motion. So yeah, although it's an ever-evolving system, the more you try and look for the spoof, the more they try and spoof you. It is something that we've considered.
It also depends, I suppose, also on the will of the potential adversary, insofar as if you deploy these camera systems globally, it's a passive system. So do they know they're being watched? So do they need to keep that spoof ongoing for the entirety of their missions, etc.? And do they have the capability of doing such a thing?
Thank you. I think that we don't have more questions. Okay. So thank you, Mission Space Team. Sorry, Team North. My mistake. Sorry, Team North. And a strong round of applause for North Team, please. Thank you. So we will contact quickly the next team, and the next team will present will be Telespacio team, and the team leader, Mr. Julian Joffrey. Hello, good afternoon, Julian.
Hello.
Are you listening? Hello?
Hello.
Hello. Good afternoon. How are you?
Yes, fine, thank you.
Thank you. Tell me, Julian, what are your expectations for today?
Hello, Brandon speaking. I'm with Julian and also Laurent. We are very pleased to be part of this challenge, and thank you for this opportunity. We are very interested in hearing a presentation from all the selected companies, and also interested in getting feedback and know if our solution can meet NATO's needs.
Okay, thank you. And tell me, are you ready to start your idea, present your idea?
Yes, of course.
Yes? Okay, so Telespacio team, go for it and good luck. The floor is yours.
Thank you. Good afternoon. Telespacio is one of the world's main players in satellite solutions and services. Telespacio France provides value-added satellite-based services covering all the key domains of space, namely geoinformation, satellite communications, satellite operations, and that includes space domain awareness. Our presentation is based on a realistic use case. We'll explain the attack of a hostile satellite on a navigation satellite that is used by NATO troops on the ground. NATO has developed a 3D satellite viewer called INSAT 3D, Telespacio, has developed, which is connected to real-time telemetry and also to open source to lines orbital elements. This dashboard allows to monitor the space situation. That means to visualize in real time the position of several satellites and detect maneuvers of hostile satellites that could affect NATO's ground operations.
Telespacio experts have just detected multiple abnormal maneuvers by a hostile satellite approaching the GNSS satellite. Telespacio is able to detect this thanks to open source data theory. This can be done with open source data used in their original condition. However, Telespacio can also improve their accuracy and reliability by merging various open source datasets using data fusion capabilities developed with our partner ShareMySpace. This unified database offers a large set of consolidated orbital data that can be used by different services, such as maneuver detection or satellite orbital analysis. To identify potential threats in orbit, such as hostile satellites, we have developed various approaches based on artificial intelligence. One of them aims at detecting and characterizing the orbital maneuvers. It is based on a neural network architecture, namely a multiplayer perceptron. In one strain, the neural network is able to recognize different maneuver types with an efficiency better than 90%. Other applications are designed to identify unusual patterns of maneuvers. For instance, the sequence of station-keeping maneuvers is quite predictable for many satellites, so that some variations can be detected by anomaly detection algorithms, also driven by artificial intelligence concepts. Another important dimension to assess a space situation is the ability to analyze the history of an object that is potentially hostile. So some statistical criteria allow to quickly determine if the movement can be deemed as usual or unusual regarding the history of the object. So this has been demonstrated by the prototype algorithm developed by Telespacio. Now back to the scenario. So thanks to our algorithms, we were able to determine that the hostile satellite has performed several maneuvers to approach the GNSS satellite. This is now only 100 kilometers away, entering the Kuiper sphere on the GNSS satellite that is monitored by INSAT 3D. Following the analysis of the maneuvers of the hostile satellite, we now focus on the NATO satellite. By ingesting telemetry data, INSAT 3D is able to detect an anomaly on the solar panel. We visualize the solar panel with the camera thanks to the team here in red. NATO forces can retrieve high telemetry relative to the positioning, communication, or other types of satellite used by NATO's forces. In this way, NATO could benefit from a record accuracy and real-time status of the satellite on a specific date. After analysis of the TMs, it can be seen that the ground links are valid and that there are no anomalies relative to the solar activity or other natural phenomena that could deteriorate the satellite. We eliminate the case of jamming of the GNSS satellite and space weather by choosing the laser shot on solar panel. Fast representation of the current state of the satellite is used very important in order to respond to occurring failures. Indeed, this 3D visualization, animated in real time, allows a much simpler approach by providing an understanding of the satellite environment and the systems, a synthetic and systematic vision of telemetry data, an ability to virtually navigate the satellite, as the alarm response route the immediate link between the telemetry or TLE. Finally, we are able to visualize the ground route to know the impact on the ground. This allows analyzing if there is a real impact for the troop on the ground or in flight. We are also able to inform the troops on the ground that there is a damage on satellite in quasi real time. We can also look at the impact and prepare a backup solution, such as maneuver on the backup satellite which will also be monitored by INSAT 3D that is able to manage constellation and all orbit types, LEO, MEO, and GEO. INSAT 3D can use public TLE data as well as telemetry data. In this way, NATO forces could visualize, monitor the position and the state of health of many NATO satellites. INSAT 3D also helps to monitor proximity detection, maneuver detection of hostile satellites. Indeed, an accurate 3D representation dashboard of the spacecraft can improve space situation around us for NATO forces. Thank you.
Thank you, Julian, for the amazing presentation. Now we'll pass the floor to the jury to ask questions. We have one question here, please.
I always have questions. It's what I do for a living. Pardon me, but maybe I'm the only one. I'm a little unclear on what your actual innovation is. It seems to be a conglomeration of lots of existing systems to help improve your ability to detect anomalies. Is there a real new innovation in there somewhere that I'm just not understanding?
Okay, thank you for your question. Indeed, the innovation is the combination of two solutions. Maneuver detection in one side and satellite real-time 3D visualization on the other side. And of course, the level of maturity is the TRL9 for our tool INSAT 3D. Indeed, the solution has already been deployed, for example, by the French agency, space agency, the CNES, by also satellite manufacturers like Thales Alenia Space or Airbus Defence and Space across multiple missions, ranging from Earth observations to telecommunication. For the level detection algorithm, the level is more close to 5, as we are in the demonstration phase. It means that we focus our innovation in the level detection solution.
Thank you. We have one more question in the room.
Yeah, this goes in a similar direction as Thales Telespazio. You have all these data, so why you have waited with the proposal until now?
Again, the tool was mainly the initial purpose was to create satellite 3D models to optimize their internal design. In addition, the tool tried to operate satellites are moving forward more visual displays, taking advantage of the increased computing capabilities available in control system. And as a consequence, Telespazio France has developed the INSAT 3D monitoring tool, which combines both strengths by optimizing the connection and to the satellite 3D models to real-time telemetry. Now we plugged this use to the space domain awareness by integrated open source data. We can also integrate commercial data and thinking specifically about the North Star data, which is a Canadian constellation, which will be launched in 2022. So the initial purpose of the tool is now deviated to the space domain awareness domain.
Thank you, Julian. I think that we don't have more questions. Thank you, Mr. Julian, and thank you, Telespazio team, and a strong round of applause for Telespazio team. Now we move on to the last but not the least team, the team Space Manic, and the team leader, Mr. Jacob Kapus.
Hello, everyone.
Hello, good afternoon, Mr.
Good afternoon.
Jacob. How are you?
Thank you very much. It's hot in here in Slova.
Are you nervous?
Yeah, I have never been speaking in front of so many military persons and generals, so frankly, yes.
Don't be. And can you share with us what are your expectations for today?
Yeah, the expectation was, or my hope was, to learn about some interesting projects and to show to Alliance our idea, and maybe I'm hoping that maybe in future we'll adopt this project or its parts. Yeah.
Okay, thank you for sharing with us. Team Space Manic, go for it and good luck. The floor is yours.
Thank you very much. Can you please see my screen?
Yes.
Yeah. Okay. Great. Thank you very much. So welcome to Space Manic. I'm now sitting in our little Houston here in Bratislava. We are a company which are dealing with nanosatellites and small satellites technologies. Our first satellite was launched in 2017, and it was the first Slovak satellite, in fact. And the last satellite we developed for the customer was launched 3 months before in March. And in the next 12 months, there will be next 3 satellites or nanosatellites we are developing right now. So that's why we know that the number of satellites is increasing, as was said many times in the previous presentations. And also abilities of these nanosatellites are growing, and the possibilities are growing. And that's there's a threat of malicious use and threatening the peaceful use of the space technology. We are also operating several ground stations here and also in the Czech Republic, and we are monitoring the satellites and the orbits, how are changing, and etc. But these ground-based solutions are very limiting. This is an example of use of ability of 30 centimeter 3U nanosatellite. The picture up there is, as we know, USA 224, and on the bottom there's this 3U, this picture from the 3U nanosatellite, and the same one is on this picture. Yeah, so the solution, or we came with this idea of the constellation of the nanosatellites to monitor the behavior of the target satellites and its subsystems. We want to collect visual and the radio spectrum data from the satellites. Actually, we are now collecting the radio spectrum data from the ground, and we are monitoring if the satellite is transmitting when it's supposed to be transmitting, or if the communication is somehow coded, etc. So we are doing it right now, but we want to do it from space. We want to determine the time and the duration of the target satellite operation and its position and attitude during its operation, imaging or something else. We need to pre-process and transfer data to ground systems for the further analysis, and the satellite will contain precise attitude determination and control system using racing wheels and some propulsion system. And for the data downlink, we will use a S-band or X-band communication. This is a very, very basic scenario. So now we have a ground segment and monitoring the satellites through the radio using software-defined radios. But if we have a nanosatellite on orbit, we can monitor the satellites right from the orbit, from the distance of tens of kilometers, let's say, and get more data and learn more about the satellite operations. So the idea is to have a full sky or all sky coverage, to have a continuous observation of target satellites as it's moving from one monitoring satellite to another, and have an ability to capture the usage of the target satellite's camera. We also make some preliminary budget. One satellite or one IOD mission should cost up to 6,000 euros, and we can do it in 2 years, let's say. So, little wrap up. So we want to build a CubeSat-based monitoring satellite constellation, which would be low cost, fast production, and it's basically proven every day, because even today it will be launched 88 satellites on the Falcon 9 rocket. We want to have a camera payload for the visual observation of the target satellite, software-defined radio for additional radio spectrum monitoring from the orbit, and ground-based infrastructure for downlink and for deeper data analysis. Yeah, so that's it. Thank you very much for your time.
Thank you, Jacob, for your excellent presentation. Now we move on to the questions of the jury, please. We have one question here in the room.
Yeah, thank you very much for your presentation. I was just wondering, how many of those do you actually need to police the space, so to speak? What's the scale of this, if it should be somehow effective for NATO to use?
Again, please, the scale of, I didn't hear the last sentence.
The scale of these monitoring satellites, how many do you need to actually be effective?
We are counting with the 9 of 3 different orbital planes right now. We did some preliminary simulations, but we need to do more. Yeah.
Thank you. The next question comes from the French Space Command, please.
Yeah, thank you for your presentation. I didn't catch the size of your nanosatellites, and you didn't mention your radio frequency payload and antenna.
Yeah, we are now simulating with a 6-unit nanosatellite with sorry, and with the antenna for the radio survey, so with the wideband antenna, and for the data downlink, we want to use S and or X-band communication, and for some basic telemetry, UHF and VHF communication.
The next question comes from the room.
Yeah, thank you. A couple questions. First off, how many target satellites can you track at any given time? And can you stop tracking them for a while you track something else and then go back to your original satellite? How flexible is it to change the tracking, the satellites that you're tracking?
Yes, I expected this question because the propulsion systems for the nano satellites are very small because it's nano. And also the attitude determination and control system is very small and not so good, let's say. But we can move with the satellite. We have one satellite with our ADCS system right now on orbit, and we can move. We have a below 1 degree precision of attitude control. So we can move the satellite in a minutes about his own axis. But changing the orbit is more tricky, let's say. So we want to use 2 different systems, the cold gas propulsion for some rapid maneuvers, let's say, and the ion thruster for the long-term orbit adjusting, let's say.
One related question. Once the target satellite knows it's being watched, or even before it's launched, they know they're going to be watched, how easy is it to either shield its activities or fool your system into knowing what they're doing?
Yeah, that is a good question. I think I don't have an answer for that right now, how to cover the satellite, but we have to work on that. Yeah.
So the next question comes from Lieutenant Colonel Roderick from STO Collaboration Support Office.
Hi, thanks for the presentation. I just wanted to make sure I understood the concept, just to clarify a little bit. So you're proposing monitoring an imaging payload of one satellite with another imaging payload to determine pattern of life and hidden mission intent. How do you determine if an imaging payload is actually active with another imaging payload? Like how does one optical payload determine if another optical payload is working?
Yeah, firstly, we want to do this radio survey to learn when the satellite is transmitting, when and what is transmitting. And with the camera, we want to do, let's say, the tomography of the satellite to do the pictures, to find out where are the main payloads, where are the main sensors located, and how it is orientated during this its operations. And maybe just this information, the orientation of the satellite changing in the time, and it is oriented towards nadir, let's say. So we can assume that it's imaging right now. So yeah, there are several approaches how we can find out what the target satellite is doing on the orbit.
So just one follow-up question, sorry. Unless you can somehow capture and decrypt the mission data coming off the target satellite, how do you validate that just because it's pointing nadir, for example, that it's actually imaging nadir? I mean, that's one scenario where you could image, but there's a bunch of others. So I just don't see, and like, how do you tell the difference between mission data or some other sort of data coming off the payload, the target satellite, to actually know?
Yeah, I think it's the learning process, because now we can see on the satellites, even when the Falcon 9 second stage is flying above us, we are receiving it with the S-band parabolic antenna. And now we can see when it's transmitting some telemetry data, some very basic packets, and when it's transmitting the real-time video. And
please, sorry,
yeah,
but the time is over. Sorry.
Thank you.
Thank you.
Thank you. And a strong round of applause for the team Space Money. So thank you very much to all the teams who presented. As I said previously, the jury will be having an hard task to decide the winner. For me, you are all winners. Let's now have a 30 minutes break so that the jury can meet and decide. This time, may I advise the finalists to have some tea rather than coffee, so that you can better control your nerves. The jury will meet in a separate room to decide who will be the winner of the NATO Innovation Challenge Spring Edition. We will then be back at 5:20 to start the closing ceremony, which will be hosted by the Admiral Chief of General Staff of the Portuguese Armed Forces, Mr. António da Silva Ribeiro. See you soon.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet, and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem, and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, space safety and security applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive, the Sun. Violent solar activity, such as flares and coronal mass ejections, can damage satellites, disrupt communications and knock out power grids. An extreme solar storm could cause 15 billion euros worth of economic damage in Europe alone. ESA is working on Lagrange, a mission to a unique point in space known as L5. By taking a side view of the Sun, the Lagrange mission will monitor solar activity and warn us of any impending risks. The third threat is space debris, a growing concern that places our vital satellites and daily services they provide at risk. There are more than 900,000 pieces of debris in orbit with a size larger than 1 centimetre. Any impact with a functioning satellite could mean end of mission. Several companies are beginning deployments of large constellations of satellites, and ESA must develop an automated collision avoidance system in order to protect spacecraft in these busy space highways, as the current manual avoidance processes will be overwhelmed. New in-orbit servicing technologies would demonstrate that Europe can remove space junk from orbit. Closer to home, another ESA project will increase safety in the skies. ESA's IRIS partnership will provide improved, secure data links between aircraft and air traffic control using satellites. It will improve air traffic management, saving fuel and easing congestion. ESA is also working to boost cybersecurity, not only within the agency but across Europe's space sector, helping make spaceflight more resilient to attack and accelerating the integration of space systems and services on the ground. By protecting our infrastructure on Earth and in space, ESA is safeguarding the assets that will secure Europe's economic future.
European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet, and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem, and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, space safety and security applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive, the Sun. Violent solar activity, such as flares and coronal mass ejections, can damage satellites, disrupt communications and knock out power grids. An extreme solar storm could cause €15 billion worth of economic damage in Europe alone. ESA is working on Lagrange, a mission to a unique point in space known as L5. By taking a side view of the Sun, the Lagrange mission will monitor solar activity and warn us of any impending risks. The third threat is space debris, a growing concern that places our vital satellites and daily services they provide at risk. There are more than 900,000 pieces of debris in orbit with a size larger than 1 centimetre. Any impact with a functioning satellite could mean end of mission. Several companies are beginning deployments of large constellations of satellites, and ESA must develop an automated collision avoidance system in order to protect spacecraft in these busy space highways, as the current manual avoidance processes will be overwhelmed. New in-orbit servicing technologies would demonstrate that Europe can remove space junk from orbit. Closer to home, another ESA project will increase safety in the skies. ESA's IRIS partnership will provide improved, secure data links between aircraft and air traffic control using satellites. It will improve air traffic management, saving fuel and easing congestion. ESA is also working to boost cybersecurity, not only within the agency but across Europe's space sector, helping make spaceflight more resilient to attack and accelerating the integration of space systems and services on the ground. By protecting our infrastructure on Earth and in space, ESA is safeguarding the assets that will secure Europe's economic future.
A European ATV supply ship burns up in the atmosphere over a remote part of the Pacific Ocean. This re-entry was carefully planned and controlled. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. Space debris can be anything from the spent upper stage of a rocket and a disused satellite to an astronaut glove or fleck of paint. There are over 129 million objects estimated to be in orbit that are larger than a millimetre, and even a coin-sized piece of debris travelling at up to 56,000 kilometres per hour will rip through a satellite faster than a bullet with destructive force.
At the moment, the most known encounters are between active satellites and space debris. An example of such an event happened in 2009, where we had a collision between an active telecommunications satellite, Iridium, with an inactive space debris satellite, Cosmos. So this collision actually resulted in thousands of fragments, and many of them are still in orbit.
Orbiting fragments can potentially hit other objects, producing more fragments and more collisions, a dangerous chain reaction known as the Kessler effect. Suggested technologies for removing space debris have so far included everything from harpoons and nets to robotic arms. Nothing is off the table. ESA has also commissioned Clear Space 1 for 2025. It'll be the first mission to actively remove a piece of space junk in the form of a Vega launch adapter.
Nobody has ever removed space debris, and it's a very challenging mission. So first thing is proving that it can be done. And that's what we are planning to do with the Clear Space 1 mission in ESA. Then the scientists are unanimous. What you need to do is to remove the big object from the most populated orbit. Why? Because those are the objects which have a higher risk of collision and which will create a cloud of smaller debris.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet, and GPS. If damaged or destroyed, the impact on society would be huge.
We know that space debris is a global problem, and that calls for global collaboration. And this collaboration is done, of course, in scientific areas, but also among agencies. And one example is the Interagency Debris Coordination Committee, IADC, where the major space agencies work together on defining the appropriate space debris mitigation technologies, forecasting the evolution of the environment, and also exchanging data and information.
ESA, a founding member and one of 13 space agencies on the committee, is also hosting the upcoming virtual European Conference on Space Debris from its site in Darmstadt, Germany. Scientists, engineers and industry will discuss the best ways to approach the problem and how to make space more sustainable. Agencies are currently tracking 28,000 space debris objects, and ESA is also developing laser tracking technology and AI-supported automated collision avoidance systems to reduce the number of false alerts for potential collisions. The aim, however, is to act now and tackle space debris before it's too late.
Locked in a stable orbit, the perfect distance from the nearest star, the Earth is an oasis in the solar system, and the only place we can be certain that life exists. But it isn't entirely safe. Today, ESA is taking a leading role in protecting our planet through a new effort, space safety and security applications. This aims to detect and mitigate threats from space and protect the Earth, society and economically vital infrastructure on the ground and in orbit. The first threat is as old as the solar system: asteroids. Most will never come close to Earth, but because there are so many, eventually some will intercept our orbit. Dangerous rocks regularly hit our planet. In 2013, some 1,500 people were hospitalized when an asteroid exploded over Chelyabinsk in Russia. At Space 19+, ministers from ESA member states will be asked to support a new planetary defence mission, HERA. HERA will be part of the first mission to rendezvous with a double asteroid, Didymos. It will investigate effects of the kinetic impact conducted by NASA's DART mission, obtaining critical science data and determining if deflection is a robust and reliable planetary defence technique. This has never been done before. In addition to making scientific observations, HERA's unique role will include measuring the asteroid's mass with extreme precision and delivering 2 CubeSats to conduct risky near-surface observations before they touch down on the surface. The next threat to our way of life comes from the star that keeps us alive, the Sun. Violent solar activity, such as flares and coronal mass ejections, can damage satellites, disrupt communications and knock out power grids. An extreme solar storm could cause 15 billion euros worth of economic damage in Europe alone. ESA is working on Lagrange, a mission to a unique point in space known as L5. By taking a side view of the Sun, the Lagrange mission will monitor solar activity and warn us of any impending risks. The third threat is space debris, a growing concern that places our vital satellites and daily services they provide at risk. There are more than 900,000 pieces of debris in orbit with a size larger than 1 centimetre. Any impact with a functioning satellite could mean end of mission. Several companies are beginning deployments of large constellations of satellites, and ESA must develop an automated collision avoidance system in order to protect spacecraft in these busy space highways, as the current manual avoidance processes will be overwhelmed. New in-orbit servicing technologies would demonstrate that Europe can remove space junk from orbit. Closer to home, another ESA project will increase safety in the skies. ESA's IRIS partnership will provide improved, secure data links between aircraft and air traffic control using satellites. It will improve air traffic management, saving fuel and easing congestion. ESA is also working to boost cybersecurity, not only within the agency but across Europe's space sector, helping make spaceflight more resilient to attack and accelerating the integration of space systems and services on the ground. By protecting our infrastructure on Earth and in space, ESA
Ladies and gentlemen, the jury has decided, and so we are ready to start the closing ceremony of the pitch day of the NATO Innovation Challenge. So, I will pass the floor to Mr. General Paolo Ruggiero, Deputy Supreme Allied Commander, Transformation. Please.
Thank you very much again. So, Admiral, with your permission, thank you. So, again, ladies and gentlemen, distinguished authorities, thank you very much for being here. Good afternoon, of course, to everybody. And let me say something just before, of course, giving my final remarks to this big event. So I want, first of all, to thank one more the Portuguese military authorities, and in particular, today, the Chief of the Armed Forces, Admiral Fernandes da Silva Ribeiro, for joining us today, this afternoon, and to co-join me to announce the winner of this challenge. The NATO Innovation Challenge is a project that I hold dear because innovation is one of the top priorities of our Supreme Allied Command transformation in Norfolk. And General Lanata, our commander, really put a lot of effort in giving to this event a lot of visibility and to give very high attention to this project. Because also this challenge represents, as a matter of fact, what we at the Allied Command Transformation, we concretely deliver day by day in the field of innovation. As recently stated by our national leaders in a joint statement following the recent Brussels summit, in light of peace, breadth and scale of technological developments, as we further develop our forces and capabilities, we recognize the vital importance of research and development and innovation to exploit the opportunities and to address the challenges posed by emerging and disruptive technologies. So NATO leaders' statement reinforced ACT commitment in fostering and leveraging innovation in order to maintain the alliance technological military over any potential adversary or competitor. In order to do so, ACT role is also to favor an environment in which nations learn from each other and find and develop synergies in the field of innovation. This is the driving idea of this challenge, to connect companies, individuals, and universities that are not historically or traditionally connected with the defense community around concrete operational topics to address military requirements of the alliance and the host nations. Therefore, this challenge is a tangible way to operationalize innovation. As you know, the theme of this 8th edition is centered on space domain awareness. The space environment is fundamentally changing and it becomes more contested, congested, competitive, and challenging, with hundreds and soon thousands of satellites being launched every day, mostly from the commercial sector. As our resilience on satellite increases, concern about their potential degradation, disruption, or even destruction have grown. Space is essential to NATO deterrence and defense, including, for instance, the ability to navigate track forces, gather intelligence, and detect missile launchers. In 2019, as you know, NATO declared space an operational domain alongside land, air, sea, and cyber. At the recent Brussels summit, Allied leaders agreed to accelerate work to deepen and to expand NATO's use of space as an operational domain. They also said the attack to, from, or within space present a clear challenge to the security of the alliance, the impact of which could threaten national and Euro-Atlantic prosperity, security, and stability, and could be as harmful to modern societies is a conventional attack. Such attack could even lead to the invocation of Article 5. NATO will continue to rely on national space capabilities for the provision of space products and services, such as imagery, navigation, satellite communications, and early warnings that enable daily operations. NATO aims to maintain a reliable access to the required space products and services in developing a relevant space awareness, ensuring relevant advice is provided to political leaders and commanders, and to synchronize efforts in all domains. In this situation, the challenge itself resolves around NATO's ability to collect and analyze all relevant open sources, information, contributing to space domain awareness, assess and prevent any disruption or denial of space-based capabilities and services, and to visualize and present space domain activities in an innovative, different way that would facilitate quick and efficient decision-making. To solve this issue, we need to rely on a wide network of partners to develop the special military capability of the future using innovative solutions. This is what the Innovation Challenge is about. And I'm extremely pleased to see that among our participants today, a significant number of small business and startups companies decided to compete. And I also very, very excited to hear that among the audience, we have many representatives coming also from different entities within NATO and outside NATO. I'm glad just to mention, it was already mentioned this morning, but I like to repeat the participant of the US NASA, the participation of a representative from the European Space Agency, but also from the STO of NATO headquarters, and also from universities such as the Old Dominion University in Norfolk, that is with us in lead of innovation, especially supporting ACT with the Innovation Hub. So this model of innovation is a win-win approach. The winners of challenges and sometimes even promising projects that didn't win get the opportunity to develop a concrete solution in partnership with the host nation and or with NATO. In addition, they get exposure and the opportunity to extend their network within the defense community. And I hope the relationship you establish during these days and during this challenge will endure further. And for the defense community, we establish contact with new partners that can provide solutions to our operational needs. But we should not forget that the real challenge will begin after today, when the proposed solutions become real capability projects. This is why in ACT we strongly believe in defining innovation as not just an idea, but above all, the implementation of an idea. And I have enthusiastically noticed that the reputation of this challenge is growing, with 41 solutions presented from 12 nations, which represent a great success for this edition. The number of participants is also increasing year after year, encouraging the expansion of an ecosystem of partners and companies, and with it the level of competitors and competition. The next interaction is planned to fall in 2021 in Canada, and I'm very pretty sure the trend will keep improving also for that edition. To conclude, I sincerely hope that today winning teams, and why not some of our finalists, can have the opportunity to bring their project to competition with us in order to deliver solutions to be operational problems and to challenge and to help the challenges that we face. As a command transformation develops space domain awareness, operational space support, and space domain coordination, we need to do so equipped with the best and brightest idea industry has to offer. Finally, in conclusion, let me please thank, of course, all the personnel of those who were involved in the organization of this project. First of all, of course, I would like to thank the team from ACT, led by Brigadier General Paul Primdal, but also all of you that participating in organizing and to finalize this big event. And for sure, again, I would like to thank the Portuguese military authorities for their outstanding support, and to express my sincere appreciation to the organization to this important event, and to congratulate, of course, all the participants. So again, thank you very much for your attention, and I look forward, of course, to congratulating the winner. Thank you again.
Thank you very much, Mr. General Paolo Ruggiero. Next, the Admiral Chief of General Staff of Forces of the Portuguese Armed Forces, Mr. António da Silva Ribeiro, will briefly talk about innovation, challenge, and its contribution to the implementation of an innovation culture of the military organizations. So, I will pass the floor to Mr. Admiral António da Silva Ribeiro.
Dear General Paolo Ruggiero, Deputy Supreme Allied Commander Transformation, a warm welcome to Portugal for the whole ACT team participating in this important event. It has been a pleasure for us to be involved in the build-up of the NATO Innovation Challenge, and I hope that all your expectations have been met. Dear Navy and Air Force Vice Chiefs, dear Dr. Vasco Hilario, Director of Defense General Resources Directorate, the collaboration between our teams in co-organizing the Innovation Challenge together with the ACT has been very fruitful. Dear Lieutenant General Barros Ferreira, Commander of the Military University Institute, I would like to recognize the strong support provided by this institute to the Pitch Day organization. Dear Presidents, Directors, Deans, ladies and gentlemen, representing several national institutions that directly or indirectly are connected to space. We thank you very much for taking part in this event, and we hope that the matters discussed here can serve for further analysis or study by the institutions that you direct or collaborate with. Dear guests, participants, and spectators of NATO Innovation Challenge, my first words go to the 10 finalists who have just presented their arguments before the jury. I would like to congratulate each one of you for the brilliant ideas that you came up with and the creativity of your proposals, which are a clear indicator of your innovative spirit and commitment for solutions to the space domain awareness. Our appreciation for your effort and our sincere congratulations on the results that you achieved. Any of you can be the big winner of this challenge, so you should all feel victorious, regardless of who comes first. I would also like to thank all participants in the challenge who for some reason did not make it to the top 10. The NATO Innovation Challenge only exists because you compete and submit your ideas to a jury of experts. I encourage you to never give up on your dreams and on your willingness to make the world a better place through innovative and challenging ideas. Thomas Edison once said, "I have not failed. I have just found 10,000 ways that will not work." This must be your attitude, an unstoppable search for new ideas and solutions for humanity's future challenges and problems. The theme of this challenge, space domain awareness, is a subject that is very close to our heart. This is mainly due to the so-called Age of Discovery, a time when Portuguese navigators introduced new worlds to the world with the help of innovative instruments while keeping their eyes on the skies. Nowadays, 500 years later, the world looks to the space in the hope of finding new worlds, different from ours. Having a clear awareness of the opportunities that space has to offer, as well as a better notion of the associated risks and threats, will allow us to find future solutions to overcome existing challenges. I believe that the work and solutions you have presented are an excellent starting point for the ongoing space exploration. It goes without saying that space is not the only challenge that countries and the alliance are facing. We are living in a time that Thomas Friedman called the age of the accelerations, which differs from the previous ones only in the speed and frequency with which, a global scale, we witness challenges in technology, society, or even in the environment. Challenges like the current pandemic urge us into a permanent adaptation and transformation of means, processes, and their ends. This is where innovation acts as the engine of organizations and of the economic and social growth. Innovation today is an inevitable reality for any winning organization. The pace at which the various actors operate, the threats are felt, and technology is developed is extremely fast, requiring innovation to emerge as a mandatory response so that our countries and organizations can maintain the initiative. As far as defense and security are concerned, I would like to highlight General Lanata's words in his vision for innovation, expressing its vital importance for the alliance in maintaining the military edge over its opponents. Therefore, the Portuguese armed forces have also embraced this posture and are implementing a culture of innovation in its various forms, open, sustained, or disruptive, in order to improve our performance in developing new capabilities. The innovation agenda is one of my priorities, as it is only through innovation, knowledge sharing, and networking that our organizations will be able to face adversity and walk side by side in building a safer and more promising future. Understanding the added value that the academic and scientific world can bring to defense and security area, we are building an innovation ecosystem in the Portuguese island of Madeira through a partnership program known as Atlantic Sentinel, involving the University of Madeira, the Regional Agency for Development of Research, Technology and Innovation, the Civil Protection and other regional entities. Under the Atlantic Sentinel program, we are developing an innovative project in the field of unmanned aerial systems with the purpose of adapting commercial drones already in use in Portuguese armed forces with essential functionalities to fulfill our mission, enabling a better exploration, management and monitoring of the vast Portuguese exclusive economic zone. This is an example of an innovation ecosystem which ensures that military organizations will not be surprised by the current high-speed change of the world. In this same vein, initiatives such as the NATO Innovation Challenge can also bring together the entire scientific, academic, and business community in the search for solutions to common problems. I strongly believe that it is through the synergy of our efforts that we will be able to act upon the present, shape the future, and bridge both. Thank you very much for your attention.
Mr. Admiral António da Silva Ribeiro. So, we have finally got to the moment wished by the 10 teams and for all participants in general. So, Mr. General Paolo Ruggiero, Deputy Supreme Allied Commander Transformation, already has in his hands the first 3 places of the NATO Innovation Challenge Spring Edition in Lisbon, Portugal. Before I pass the floor to the General Ruggiero, I would like to ask to our finalists if anyone would like to share with the audience what you are feeling right now. Teams in the room, share my space? Ratus? Teams online. Anyone? Anyone can share? Are you nervous? No, because I am.
I just would say we're feeling very much excitement at seeing the results and appreciation at seeing all the pitches from all the other teams. It was very impressive to see the cool innovation coming from around the NATO countries.
Okay. Anyone? No, I think so. So please, Mr. General, the floor is yours.
Thank you very much. It's a very great pleasure, as the Portuguese Chief of Staff just mentioned before. Yes, of course, every challenge has a winner, but at the end, everybody is a winner, because as I mentioned also this morning, just the fact that you participated to this challenge, and you arrive also to compete up to the last stage of this challenge, I think is a victory for everybody. And I really wish that your project, your proposal could be relevant, not just the one of the winner, but all of your proposal could be relevant, of course, and help NATO to maintain its advantage, as General Lanata also mentioned in his vision. So are we starting with the number 3, I believe, right? Number 3. Okay, the third place goes to, I hope that I read correctly, third place. Okay, are you ready? We need some drums. No, never mind. Okay, I think it's better. Yes. Okay, I think can you hear me better now? My English is not very good, but without mask is better for sure. Okay, so the third place goes to the VI2 War for University of Calgary. Okay, can we have somebody from the University of Calgary just to say a few words? Is anybody in line?
Yes. So thank you so much. I'm very proud to accept this on behalf of the great team that we have at VisWorks and the University of Calgary. And we look forward to talking further with NATO and progressing this, and also with the Canadian Defense Department. So thank you, amazing.
Okay, thank you very much to you and to your team, of course, and congratulations. Okay, second place goes to Mission Space. Okay, anybody from Mission Space representative who would like to say something?
Yes, I'm here. So thank you. Thank you so much for this award. Thank you so much for this opportunity. We're super proud to be taking this place. And again, thank you for a great organization. And we hope to speak with you guys further.
Thank you very much to you and to your team as well. And congratulations. And now the winner. It seems like I'm in Hollywood, you know, I'm the winner of the Oscar. Anyway, so the first place goes to Share My Space. So congratulations. Excellent. Oh, we are here. We have your representative. Please come forward to join us. And I leave the mic to you if you would like to say something.
Yes, that's a great pleasure to be the winner of the challenge. And that was a very interesting afternoon. We learned a lot of things from other team. And yeah, we'd like to thank everybody here in Lisbon for the organization and say hi to the team back in Paris because we won it. And so we'll come back and we can debrief this victory. So thanks a lot for the organization, and a great pleasure to be the winner of the challenge.
Thank you so much. I think General Lanata will be very pleased that you won because he is also from France. So I'm kidding, of course, doesn't mean anything in the country. But again, thank you very much for participating and congratulations to you. I think now is the, yes, I know we need to Probably we need to move. Can I ask to the admiral also to come? Because I think we need to do together.
Yes, yes, of course.
And we need also to go to the right side. In front, yeah, I think it's better. Yes. Okay, I need to wait. You can stay in the middle.
Yes, carry on. Thank you, Mr. General. So let's find out what the winners, the online winners, have to say or share with the audience, please. So I asked to share my space if you want to share with us what are you feeling in the moment, please. But you can share now? No? You have already. So VisWorks and University of Calgary. Jeff.
Well, just excitement. This is amazing, and I'm super happy to be amongst the top three. Certainly congratulations to the other two winners and to all the finalists. It's been, as I said, amazing to see all the cool innovations, and we look forward to working on this going forward. So very much happy about this, and also very proud to be from Canada with our team from Canada and opportunities to work with the other Canadian teams, and look forward to the next event in Canada, which I hear is coming up in the fall. So I'm looking forward to that one too.
Yes, thank you. And the second place, please, can you share with us your feelings, your emotions?
Yes, absolutely. So just super excited again. That was really unexpected for us. Cannot wait to share with our team what's coming up. Also super proud to be from Latvia. And again, thanks so much for this opportunity.
Thank you. A strong round of applause for the three winners, please. Well, I know your emotions are running high, but we are finishing the event and we can then go to celebrate at a cocktail party with some port wine offered by the Director General of National Defense Resources, Mr. Vasco Hilario. But before that, can I ask you a bit more of your attention, please? Portugal has to hand over the NATO Innovation Challenge to our next allied country. And as you already know, the next NATO Innovation Challenge Autumn edition will be hosted by Canada. So we have with us the Acting Deputy Commander of Canadian Special Operations Forces Command, Brigadier General Martin Grosjean, and the Director General of Innovation for Defense Excellence and Security, Mr. Eric Fournier. Good afternoon, gentlemen. How are you?
We're pretty good, I think. I don't know if Eric is pretty good.
I am as well.
Okay, first of all, congratulations of being chosen to host the autumn edition of the NATO Innovation Challenge. We wish you every success in the journey that is now beginning on your side. I know that both of you wish to address some words related to the challenge. Mr. General Martin Grosjean, the floor is yours, but I just kindly to ask you to be brief, please. The floor is yours.
Thank you very much. I'll be really, really brief. Again, I'm Brigadier General Martin Grosjean. I'm Acting Deputy Commander of the Canadian Special Operations Forces Command. It's a privilege to address you today. We have long recognized that to remain safe, secure, prosper in a global stage, we must remain innovative and adaptive to changing circumstances and environments. Events during the past few years, particularly the emergence of strategic competition, have reinforced the vital role that NATO serves and how important our membership is within it. Thus, let me express how proud and excited that Canada is to host the next NATO Innovation Challenge that will take place in November of this year. Our specific challenge, which will be announced in early September, will be a collaboration between the Canadian Special Operations Forces Command, also known as CANSOFCOM, and the Department of National Defense Innovation for Defense Excellence and Security Program, also known as IDES. As a Special Operations Command, innovation is baked in into our organizational culture. As a result, we are often at the forefront on operation, as well as in developing and integrating new technologies and concept into operations on behalf of the Canadian Armed Forces. CANSOFCOM places a high priority on building, strengthening, leveraging our innovations ecosystem in order to secure competitive advantage, and we're eager to expand this network into the broader NATO system with this challenge. At this point, I would like to invite my colleague, Mr. Eric Fournier, Director General of the IDES program, to say a few words.
Bonjour from Ottawa. I hope that you're all doing fine this afternoon. So thank you very much, Brigadier General Grosjean, for the introduction, and also to General Ruggiero for having me today and talking about this exciting announcement. I'd like to congratulate our Portuguese colleagues for running a very, very good, successful pitch day event. The bar is very hard for us in Canada now. And on behalf of Canada, we're excited to accept this important leadership role for the NATO for partners. The Department of National Defense, and more importantly, Canada, recognizes the importance of defense innovation. Our signature defense innovation program, IDEAS, so Innovation for Defense Excellence and Security, is there to help increase defense capability for the Canadian Armed Forces and working with innovators across Canada and around the world. So competition is a great way to energize innovators, as we've seen from these presentations today. So I'm very happy to have my team work with their expertise, skill, and knowledge to strengthen our collective defense posture. So with CANSOFCOM, our close partner, we're uniquely positioned to help deliver on this important mission. And well, we'll see you in the fall. So thank you very much.
Thank you, Mr. Eric. Portugal and the whole team who organized this challenge are at your disposal to help Canada in whatever is required. I look forward to the invitation to Ottawa or Quebec City for the next pitch day. It is possible?
It's probably going to be virtual, though.
Oh. I'm so sad now, right now. Okay. Ladies and gentlemen, with the authorization of Admiral Chief of General Staff of the Portuguese Armed Forces, Mr. António da Silva Ribeiro, the pitch day of the NATO Innovation Challenge Spring Edition, Lisbon, Portugal, is now over. To the guests present, the Director General of National Defense Resources, Mr. Vasco Hilário, invites them to proceed to the cocktail, where we will toast and celebrate this event in the very traditional Portuguese way, with a port of honor. Thank you for your presence. Have a good journey back to your countries, and above all, stay safe. Have a nice evening and goodbye. Thank you.